Jai Hind to all. A very warm good morning to all of you. It gives me immense pleasure to extend you a very warm welcome on behalf of Research and Development Cell, who has clubbed all of us for the workshop Recent Advances in Aquaculture and Fisheries Sciences. I, Dr. Nisha Rana, Assistant Professor, Zoology, Swami Vivekanand, Subharti University, on behalf of Organizing Committee, welcome Chief Patron Dr. Atul Krishna Sir, Patron of the webinar, Honorable Vice Chancellor Sir, Professor Major General G.K. Tapliar Sir, Honorable CEO Ma'am, Professor Dr. Shalyaraj, our Provici Sir, Dean Academics, Director Research, Professor A.P. Garg, Joint Director Research, all deans, principals, HOI, HODs, scientists, participants, faculty members, and students. I also welcome all the speakers. I also welcome our chief guest, Professor S.N. La, President, Nepal Aquaculture Society, and speaker of our workshop, Professor Veena Batra Kushwaha, Professor and Head Department of Zoology, Deen Dayal Upadhyay, Gorakhpur University, Gorakhpur, Professor H. Shivananda Murthy, Chairperson, Division of Fisheries Science, Danyawatia University, West Bengal, Professor Binay Chakrabarti, Executive Director, Mud Crab Center, Aquaculture and Management Center, Bangladesh, Professor Dilip Jha, Head Department of Aquaculture, Faculty of Animal Sciences, Veterinary Sciences and Fisheries, Agriculture and Forestry University, Chitwan, Nepal, and all the eminent scientists, faculty members, research scholar, and aquaculturist. I warmly welcome you all. Before I start, I would like to introduce the e-workshop. As you know, fisheries have been in the spotlight as the fastest expanding food producing sector during last 3 decades. It produces employment for a large coastal and non-coastal population, promote nutritional standards, boost food supply, and creates foreign exchange. Fisheries resources, unlike mineral resources, are self-renewable if properly managed. Production from catch fisheries has increased in recent years. The e-workshop is aimed to provide technical knowledge with the necessary ability to manage and conserve the developing countries' diverse fisheries resources in order to provide food security and for providing necessary knowledge of various aquaculture and fisheries production system. Now, I would like to invite our chief guest, Professor S.N. Love, for his address.
Am I audible?
Yes, sir, you are audible.
So, respected chairperson of e-conference, uh, all the dignitaries, they are online and offline, dear friends, dear faculties, and all the supporting staffs and members, and those who are listening my word. It is a warm welcome and very good morning to all of you. It is a matter of great pleasure that today we are going to um, organize and interact with each other regarding the recent advances in aquaculture and fisheries. Dear friends, aquaculture and fisheries, there are two words. One is aquaculture and other is fisheries. So I belong to Nepal and I'm president of Nepal Aquaculture Society. So I am giving more focus towards the aquaculture rather fisheries because fisheries comes under the aquaculture. So both are directly related to the food production. There are two types of food production. One food production will be on the land, and then we use the term agriculture, while this is the food production in the water or from the water. So this is called aquaculture. Inside the aquaculture, there are varieties of animal production, but most of them, our main focus will be fish and fisheries. That's why we use the term aquaculture and fisheries. So basically, our more focus is the food production, and food is directly concerned to the livelihood, and livelihood is for the socio-economic development of the country or anywhere in the world. So India is the second largest country in terms of this aquaculture production. And we are very close to the India. This is the open border. Our water system, our ecosystem is directly connected. We can go and come without any hesitation. So I believe that the fisheries and aquaculture, or aquaculture and fisheries in Nepal and aquaculture and fisheries in India, is quite common, and technology is common, and our understanding is also common. So I'm not going to give you the more and more information with this, because this is the inaugural session. So I just give the great message, gratitude message to all this organizing committee to have a grand success of this program, and let us enjoy all the deliberates, all the dignitaries who will give their idea and sharing regarding the aquaculture and fisheries in this during the session. Thank you very much.
Thank you so much, sir, for enlightening us. Now, I would like to invite Dean Academics, Professor Amar Prakash Gar, to say a few words.
Very good morning to all, and thank you very much for giving me an opportunity in the inaugural session. And as you all know that fisheries is one of the most important aspect of the food system. And nowadays, you know that 8.2 billion population at present we have, and by 2050 we will be having the 10 billion population. And to feed the 10 billion population, we will need 56% more land, and the land area will be reduced. It will be reduced by 18%. So now how we will be able to feed this population of the 10 billion by 2050? The answer is very clear. The answer is that we will have to depend upon the fisheries and the microbial foods, because the agriculture will be also affected due to the climate change. The second point which I would like to mention over here, that the fisheries, it is one of the very good item as a food. It is a complete food. It provides a variety of nutrients, variety of minerals, variety of growth factors, and the variety of things. The another very important thing which I would like to mention over here, that is the rising sea level and the rising acidity of the oceans. It is one of the very important factors which we need to discuss in this vital workshop and the conference. Now, this rising sea level or rising acidity level, it is going to affect the diversity and the population of the fishes, including the marine flora and fauna. And one of the very important thing which everybody should keep in mind, that the alkaline food is good for the health. It promotes the gut microbiome, it promotes your health, it protect against the several diseases. So we will have to think over here that how we can reduce the increase of the acidity of the oceans to protect the marine life and the marine flora and fauna, particularly the fishes. Because if the fishes, they are surviving under the acidic environmental condition, then the type and the quality of the fish will also be changed. And when it will be changed, it will affect the diet and the health of the people. So, to protect the marine environment, we will have to decide over here that we will have to stop the use of the plastic and polythene in the e-waste, particularly when we are dropping all these things in the ocean. We will have to frame a policy at the international level that these things should not be dumped in the ocean, and the microbial diversity of the ocean need to be protected. Without the protection of the microbial diversity of the ocean, we cannot control this increasing acidity and the decreasing power of the oceans to degrade these non-biodegradable waste. And the phytoplanktons population and the phytoplankton quality, alkaline quality, also affect the quality of the fish and the quality of the nutrients in the fish. So we will have to stop the pouring and dumping of the e-waste, electronic waste, plastic, polythene, and all these in the ocean. And we will have to also think about it, that how to stop the increasing water sea level, because you are seeing that Nowadays, this climate change, it is going to make the big effect on the human life and the life of the earth as a whole. And these are the some of the factors which we need to discuss in the vital conference. And I wish the all the very best to the organizers of the conference. And this will give an insight and the good opportunity for those who are participating in this conference to interact online with the various scientists and industrialists and the professionals who are in fact working in the fisheries. So thank you very much and all the best for this wonderful 3 day conference being organized by Dr. Nisha Rana, a part of the research and development cell. So thank you very much. Thank you.
Thank you so much, sir, for your motivating words. And now I would like to invite our keynote speaker. Before inviting, I would like to introduce him. Professor H. Shivanandan Murthy is the Dean and Chair Professor of the Neotia University, West Bengal. He served as Dean of the College of Fisheries, Mangalore, and Registrar, Karnataka Veterinary and Fisheries University, Bidar, Director of Extension at same university and at the headquarters of Bidar, and formerly Professor and Head Department of Aquaculture, College of Fisheries, Mangalore. He has total serving of 40 years of different cadres. He is an alumnus of College of Fisheries, Mangalore, and obtained his bachelor, master, and doctorate degree in fisheries and aquaculture from the University of Agricultural Sciences, Bangalore. Sir has guided 44 research scholars of their high quality thesis research work as research guided in aquaculture, fisheries science in University of Agriculture, Bangalore, KVA FSU Bidar, and at the Mangalore University in Biosciences. He has a strong research background and served as principal investigator of 17 externally funded major research projects in the area of agriculture, aquaculture and fisheries science funded by International Foundation of Science, Sweden and other international and national funding agency, and brought sustainable research grant to the university and created infrastructure facility in the form of Center of Excellence and Extension Education, E-Resources Center, fish prawn hatcheries, pond laboratories, and facilities. Sir has published more than 200 publications, out of which 148 research papers in national and international referee journals, 17 books, and other publications. He has postdoctoral foreign research assignment in prestigious university, namely University of Stirling, Scotland, UK, Texas A&M University, USA, and University of Santiago, Spain, and had short-term visit of Denmark, Singapore, Norway, Netherlands, Malaysia, Thailand, France, Belgium, Germany, Switzerland, Australia, Sri Lanka, Hong Kong, Dubai, and other countries in connection to research and development, including chairing the technical session and presentation of keynote address lead paper in international conferences. He is the recipient of many awards, including Jawaharlal Nehru Award by Government of India, New Delhi, Sir C.V. Raman Award by Government of Karnataka, Best Researcher Award by University of Agriculture Sciences, Bangalore, Overseas Fellowship by Department of Biotechnology, Overseas Development Administration by UK, International Foundation of Science and Sweden, and other award and recognition. Professor Murthy serves a member of various national and international prestigious high-level technical committee, including National Committee of Planning Commission, New Delhi, for expert advice in fisheries and aquaculture for formulation of 12th year 5-year plan, served as member of Karnataka Biodiversity Board, Bangalore, member of Technical Advisory Committee of Karnataka State Pollution Control Board, Bangalore, member of the Research Advisory Committee of ICR Central Institute of Freshwater Aquaculture, Bhubaneswar, sitting member of RAC ICR Central Marine Fisheries Research Institute, Cochin, and served as member of various national committees, including member of Selection Committee of Agriculture Scientists Recruiting Board, New Delhi, Indian Council of Agriculture Research, New Delhi, and served other university and organizations. He has organized more than 16 national, international conference workshops as director, organizing secretaries in fisheries and animal sciences. Professor Shivananda Murthy has organized more than 61 national state level training programs as course director in aquaculture and fisheries in animal sciences for benefit of farmers, officials of the State Department of Fisheries, Animal Husbandry, KMF, KVKS, and other department level. He has attended 20 international, 35 national conferences, workshops, and presented lead paper in and chaired many technical sessions. He is also associated editor of International Journal of Aquaculture and Marine Science USA. He is also a member of editorial board of International SDRP Journal of Aquaculture, Fisheries and Fish Sciences USA. He is also a member of editorial board of Journal of Aquaculture in Tropics. Served as office bearer member of various scientific societies in India abroad, including professional organizations, including president of All India Professional Fisheries Graduate Forum, Mumbai, and other bodies. Now, I would like to invite Professor H. Murthy to deliver his talk.
Uh, Thank you, Dr. Nisha Rana, for your introduction. So, a very good morning to all of you, all the participants within the country and abroad. Hope I can. I think I'm hearing audible, right?
Yes, sir,
Yeah.
you are.
Okay, okay. So I am going to present a talk on the what is the called keynote address on the recent advances in aquaculture and its sustainability and innovations. I think yeah, you can just go through the slides. Yeah. So, the exact title is Recent Advances in Sustainable Aquaculture Production and including Innovations. Probably you're all aware this aquaculture is gaining a lot of importance in the recent years, not only in India, also globally. In fact, uh, people call it is potential area for not only food production, is a nutrition and national economy. When I say food production, it is the best way of and fastest way of animal production, animal food production. That means animal means mainly fish production. Then when I said nutrition, because the food, fish food is the most healthiest food. Probably you are all aware that how the nutritional benefits of the fish, including the UFAs or omega fatty acid that are rich in the fish, and the essential amino acid profile. Then we have various vitamins, vitamin D, vitamin A, and minerals, etc. So that's why always, people or any health conscious people prefer fish rather than any other meat, animal meat. So even we here the doctors prescribe you take eat fish as much as for any patients, especially for anemic patients. Advised to take fish as much as fish, but they also say don't take pork or mutton, chicken, because they contain more of saturated fats. The healthy is unsaturated fatty acids, highly unsaturated fatty acids. They're rich in fish. That's why it's considered the most healthiest food. And even it has been proved through research beyond doubt that it has been helpful for maintaining the health of the heart, coronary, all problems and heart problems are solved among the regular fish eating people. Then arthritis, blindness, it has been proved that the fish eating people will have very less of these problems. So that's why in the recent days, fish is considered one of the best, healthiest food. Okay. Yeah. So I also mentioned fish for wealth and fish for health. That is the already explained. Wealth in the sense, the national economy, the family, for starting from family income to the national economy. So that is a greatest contribution from aquaculture and fisheries. Then also mentioned about the health, how fish is important with regard to health. And of course, in this regard, FAO, the Food and Agriculture Organization, a global international organization, the UN organization. It actually monitors and regulates world over about the fisheries development, and also the fish catch statistics. Every year they compile the fish catch statistics worldwide, and very nicely interpret and present it, and distribute to all the governments. So that is the authentic data we call Sophia, a state of fisheries and aquaculture in the world. So every year, so there is also a committee on fisheries. So they also decide once in a while about the what intergovernmental policy decisions with regard to aquaculture and fisheries. Yeah, maybe just you can see here the trend in the production, fish production, and also its contribution to the world. Uh, to mention about the recent, fish productions, the world fish production in the just last year is something like 214 million metric tons. That is the all-time highest fish record. Out of which 156 million tons come usually goes for human production, human mainly as a food, human food, but remaining so for industrial fisheries or non-food, we say used for fish meal, various other industrial products. Okay, so out of this total global fish production, 87.5 million metric tons comes from aquaculture. Aquaculture, there is a tremendous increase in the aquaculture production in the world over in the recent years. Earlier we will capture fisheries or the what is called wild fish production coming from seas and oceans. It was been contributing to a large extent, but in the recent years, aquaculture production is taking dominant contribution in the world fish production. And so the latest contribution from capture fisheries is about 90.3 million metric tons. And every year, of course, the overall global capture fish production continues to remain stable. Sometimes, in some countries it's going down, or sometimes it's stagnate. And whereas on the other hand, as I mentioned, aquaculture production is going at a higher speed. You can also see here, it is presented here, the production, year-wise production, how the fluctuation in the production. Then, yeah, so also you have in aquaculture, there is another major input is a feed, that fish feed, or we call aqua feed. That is also increased, threefold, about 7.6 million tons in 95 to into 29.2 million metric tons. The production going, increasing at an alarming rate of 11%. So the aqua feed production is expected to continue growing at a similar rate. It's about 71 million metric tons. And world fish production is expanded almost 12 times. When you compare in the last decade, 12 times at an average of 8.8% growth per annum. So globally, fish provides about 3.1 billion people with an almost 20% of their intake of animal protein. So out of what are the animal food or any meat they eat, out of 20% comes from fish protein, or and then 4.3 billion people get about 15% of such protein. Yeah, so India, this is about briefly a global scenario as aquaculture and fisheries status I just mentioned. Then coming to Indian production, India, stands third in the world in the fish production, next only to China and Indonesia. In fact, in the last few years, India was our second as far as the aquaculture production is concerned in the world. But in the recent years, the Indonesia has taken over, and so India now stands at third place. The total production of the country is something like 16.2 million metric tons. This is again an all-time high record of fish production in the country, out of which we have 12.1.2 million metric tons comes from aquaculture, including inland fish production, and only a small contribution of 4.13 from marine capture fisheries production. Here again, I can stress here, in early 50s, 1950s and 60s, over 90% was from capture fisheries, the total country's production. Whereas in the last few decades, the aquaculture has taken over so much that the potential, the production has increased drastically and dramatically, and to the highest level of about 12.12 million metric tons, and contributing to total 16.2 million metric tons of the country. So India exported fish and fishery product to overseas markets to the tune of 57,586 crores. That is a huge contribution from export fisheries market. In other words, fish and fisheries products are exported to different countries is getting a lot of foreign exchange to the country. That is one part, great thing. And total in terms of quantitative terms, it's about 113 136,092. So 13, you can see how much it's almost 13 million metric tons, something like that. So in terms of quantity, and this is in terms of value. Value is 57,586.5 crores. Yeah, of course, this is, you can see on the sides, we have some photographs where aquaculture, actually our students are doing aquaculture activity. They're dragging the fish, and some photographs are here and there I have posted. Then, if you see, this is the Government of India data and the Ministry of Fisheries compiled. The same thing, say, represented here in the form of figure. You can see 16.2 million metric ton total production, and this is some marine production, 4.12 million metric tons. This is in terms of lakhs, so but I mentioned in terms of million tons. And similarly, you can see here inland and aquaculture production, 12 million metric tons. Then quantity of products exported, 13.89 million metric tons. So then we can also see here the contribution of fisheries sector to the Indian economy. So it's call it a GVA, or sometimes earlier GDP. So that is something like 232,000 crores to the country. Okay, so here in terms of GVA, 1.21% over a gross domestic GDP of the country, 1.1%. Whereas if you consider agricultural products, because always fisheries is sometimes clubbed with agriculture. So if you take as agricultural economy, it's about 6.72. And here this is the quantity that is already I mentioned in terms of rupees, 57,000 plus crores of rupees that country has got through export of fish and fisheries products. Yeah, this also I mentioned just now. And in India, it contributes to 8% in the total world aquaculture production. So Indian production contributes 8% of the total world aquaculture production. And in India, the total amount of commercial fish feed production estimated to be about 247,000 tons of production has been there. So this also I mentioned earlier about that. So in aquaculture has become a key player in ensuring the stable and sustainable food supply. In fact, this section introduces the significance of aquaculture and related biotechnological process in meeting and increasing the demand for fishery products. Recent advances in aquaculture and biotechnology have significantly improved the industry's sustainability and productivity. These include, effective micros, bioflag technology, then RAS, that is the recirculatory aquaculture systems, aquaponics, aquamimicry, triploidy, and polyploidy, then vaccines, probiotics, prebiotics, and Internet of Things, and water quality, Internet of Things for water quality management. So here you can see in the photograph the fish being injected for breeding, especially these carps. They are injected Katla, Rohu, Mrigal for breeding during the breeding season. Then the biotechnology, the bioflag technology, shortly BFT, has gained attention as an efficient aquaculture alternative. It focuses on boosting biosecurity with minimal water exchange and reduced feed intake. So here the significant feature is it minimize the water requirement and also the reduced feed intake, because these are the two things where a lot of involvement of money, cost is reduced. Then this BFT release on apply organic carbon to maintain a high level carbon nitrogen ratio of more than 10%. This is very important carbon. So there here something, anything organic material, some sort of people, farmers can apply sugars or molasses, any other thing that carbon source to uh, have a carbon nitrogen ratio, so that here the autotrophs will assimilate the toxic nitrogen, contributing to a healthier aquaculture system where ammonia and other toxic gases are substantially reduced. So this is a typical bio flock system, indoor bio flock system. Then modern fish farming systems include, this uh, the researchers are now working to identify viable technological solutions that ensure the final product meets standards of food safety and security. That is very important, because when any farmer, fish farmer, exports the fish and fishery products to overseas market, in food safety is very important, because I mentioned so much of fish. Fish is exported to overseas market and got a lot of money to the in the form of foreign exchange of the country. That depends upon the food safety and security, because high standards have to be maintained, and there, if anything, any some pathogenic bacteria or other microbes are detected, the product will be sent back by these countries, maybe Japan or US, European countries. That's why safety, food safety standards is very important. By adapting feed to the nutritional requirements, then here actually when you consider feed, fish feed, so nutritional requirements are very important of the cultured species, and the carrying capacity of the pond or a system where fish are cultured, because we cannot culture a huge number lakhs together in a small pond. So there is a limit that we call it in biological terms carrying capacity. So only limited number of fish, required number of fish only can be cultured. And then only the farmer will get good production. These practice optimize applied technologies to achieve high fish production with minimum cost. And here also this is another biofloc system. You can see how here they use the pond lining for the so to minimize the water seepage. And India is the primary market for aquaculture feed as a wide diversity of aqua species contributes to domestic as well as export market. When I said feed, so it's not only for domestic and also export market. There are a good number, several feed companies are there in the country, very big companies. So most of these feed companies are located in Andhra Pradesh, along the Tamil Nadu and Orissa, West Bengal. So these feed companies are producing a huge quantity of feed, and so they are not only meeting the domestic demand and also exporting the feed. They may be fish feed or shrimp feed. Uh, so then we say fish and shellfish. We together we call it. Shellfish means shrimps, prawns, and other crustaceans. So that altogether fish and shellfish feed. In India, aqua feed sales moved from an unorganized retail channels like earlier, there is wet feeds, wet market, and to organized retail channels like supermarkets. Then, because of these rising disposable incomes, then more health consciousness and improved wholesale facilities. Again, here, so when I say feed, it is also the quality of the feed is also important, because we cannot feed the fish with lot of wet feed, because it's a huge pollution, calling pollution in the pond or the system. Because probably you're aware, somewhere here, the fishes like African catfish and other fish, they are illegally cultured. Although African catfish is banned in India, culture. And you know what type of feed they give? Something waste from the hotels or even any other waste, animal waste, poultry waste from slaughterhouse. They put to the pond, and these fish, the voracious, they eat everything, and but the pond pollution is terrible. So such feeds are not advisable. They should not be given to them. Not only the pond system is polluted, and then also the health conscious people will not prefer such fish grown in such using the waste, or sometimes in sewage and all fish culture. That's why the quality of feed is very important. Where in the presently the we scientists advise only to use the pellet feeds, dry feeds. They manufacture in the pellet mills, or we have another group of feeds called extruded feed. Such feed should be used because the quantity is useless, and the feed given to the pond or system to be used 90, at least 95, 98% should be utilized, because maybe wastage will be very minimal. So then water quality can be maintained, and it is sustainable for a long run. So that type of fish should be used. The quantity of fish caught also increased, or this already I mentioned how the fish, the total production of the country has been increased of 16.4 million metric tons in the last year. So this also you can see here, my students are doing the various works with injection and breeding work and other activities, especially culture and hatchery activities. And Indian aquafeed mills can produce up to about 2.9 million metric tons, feed. And as I mentioned, Andhra Pradesh is the largest fish feed consuming state. Now, consuming and also producing. Most of the feed companies are located in Andhra Pradesh, Bhimavaram, Nellore, those areas. I have visited, of course, several feed companies and fish farms. This is also called something, aqua hub or a hot belt of Indian aquaculture, where is Nellore, Bhimavaram area. It is clear that the aquaculture industry is enormous in India, which provides vast opportunities and potential for aquafeed industry. So then, when I consider feed, I said good quality feed, but at the same time, the farmers are not afford to pay very expensive feed. The cost of feed also should be very less. We call cost effective feeds instead of low cost. We cost effective feed. And so, when you think about cost effective feeds, replacing the animal protein sources with plant protein sources is very important to reduce the cost. For example, animal protein source, mainly the fish meal was used earlier as the protein source in not only fish, of course, shrimps, all our aquatic animals. But in the recent years,
Jahin, I think there is a network issue. Sir will continue within few minutes.
they don't actually strictly require any fish meal. But of course, fish meal is very much required for shrimps and prawns, at least a small portion of that. But the supplementary feed is given here. It says mm, that means to meet the additional requirement. What is natural food is not able to meet the requirement, so we give supplementary feed. That again in the form of pellet feeds only. So you can see here, when I visited last month, Bhimavaram, that area, Nellore, and also you can see the check trays are used for especially in the shrimp culture. In shrimp culture, Penne, Smanada, Manname. So how to the utilization of the feed, and also to check general health of the fish. That they lift the check tray and you see how much the feed is wasted or eaten or not, and you can manipulate the feed to give the feed. We can increase or decrease depending upon the the feedback that we get from the check tray. And biotechnology, of course, plays a crucial role in
I think there is a network issue. So slide is not moving. I think there is a connectivity issue with sir. So the lecture will be starting within few minutes from the same slide.
was lacking. Then on par with agriculture, animal husbandry and engineering. This higher education bachelor degree in fishery was started from Mangalore Fisheries College in 1969. Then later, the colleges were established in Tamil Nadu, then Kerala, then Andhra Pradesh, Maharashtra, and other governments. Like that, probably today we have, I think, more than 40 fisheries colleges in the country. Even some of the private universities have established fisheries colleges, and that's why we have now a pool of professional fisheries graduates, and they are who can capable and manage the fisheries and aquaculture industry, public and private in the country. This is just about the education, higher education of the fisheries, the developments I just mentioned. Then biotechnological tools have also been employed to enhance aquatic food production. Then genetic improvements, the value addition to fish products, food preservation, fermentation, packaging, and quality control. These are all comes under post-harvest technology. We also call it a fish processing technology, a post-processing technology, wherein the value addition is very important because fish not just eaten as a fish flesh, just a curry or fish fry. Various other products can be produced. Like various fish cutlets. You can see here our students are prepared in the internship program and annual scheme program various fishery uh, value added products like cutlets, then samosa, then fish pickle, prawn pickle, puppets, vapors, everything can be prepared. That means to increase the protein, fish protein in the food, so that fish people who are not able to eat fish directly, indirectly they can eat. So to derive the nutritional benefits of the fish. So the development of then sensitive and portable biosensors for detection of foodborne diseases and pathogens. That's also another important area where a lot of improvements have been done. Maintain of the water quality is very important using some of these sensors and probes. Okay. To address these concerns about ecological sustainability, uh, the integrated, multi-trophic aquaculture. There is another area. Then triploidy, the gene technology, based type like DNA, and also I said earlier about gene uh, uh, manipulation in fish. That's also has been done. Lot of work has been done by the scientists. And shrimp aquaculture has seen advancements in wastewater management and use of nanomaterials and bioflak technology. Bioflak I already mentioned. In nanomaterials also used in various forms of shrimp culture, and also uh, we have used seaweeds. Seaweeds is also another area where they can be used. Lot of uh, bioactive compounds have been extracted from the seaweeds. Then development of information and digital technologies such as artificial intelligence, aquaculture, recycling systems, and blockchain, etc., have been proposed to increase efficiency and sustainability in aquaculture and fisheries. These are also again view of some fish ponds, especially this is from Mangalore, College of Fisheries, Mangalore, and this is the form growth forum. You can see where a big ponds enhance the immunity of fish and shellfish. Then probiotics and prebiotics. Probiotics such as that aid the health gut health of the fish and our shellfish and gut microflora increase that will help. Then prebiotics is also another group of compounds that will be useful for the fish and shellfish to enhance the immune system, enhance the immune system and disease resistance. Then bioremediation techniques, using microorganisms to break down pollutants and maintain water quality in aquaculture system as part of environmental management. In aquaculture is not just producing the fish. Earlier farmer in the beginning, probably several decades back, they're thinking only to get production. That means as I has production, for example, in carp culture, they would say 20 tons per hectare, 25 tons, like that. That was the thinking that time. But even shrimp culture also, because there was a boom in probably early 2000, they got a very huge profits, especially shrimp culture in Penes, Manodan culture that's called tiger shrimp. But later, not only scientists, even farmers realized that it is not possible to get high production like that. Suddenly they cannot become rich overnight. So they realized there needed to be a sustainability because the system should be sustainable. And I said carrying capacity of the pond earlier. So like that, now the EU farmers realize that so they have to maintain the system. Then mainly water quality. Here, water quality is very important in aquaculture, and especially they cannot use any antibiotics or other drugs and chemicals. They are all banned. So most of them are banned, and especially even any traces available in the fish and fishery products that exported to overseas markets, they will be returned. They will be rejected. Then the exporter will face a huge loss. So that's why the quality is very important. Not only water quality, but also what they use either in the feed or in any other form they apply to the pond is very important. That they should not use any and only permit. There are some permitted accidents or antibiotics limited way. When there is a disease, they have to give only certain days. We call medicated feeds. You mix with the feed, you give just for 3 days or 5 days, they stop it. Not regularly giving in the feed. Some farmers unknowingly they do no so that they will not get any disease like that. So that is very bad, and affects the not only pond but also fish immunity, because the fish, once the immunity is lost, they cannot later no any medicines or any drugs will not be effective against the same bacteria or microbe if they apply. So this is we also used to do a lot of work and extension education to educate the farmers. So one such area where I think previous also we have something like that. Then this is to popularize to educate the farmers. So this harvested from a farmer's part. She is the farmer, and so we organize in a field day and a meeting of like some sort of a workshop, field workshop in front of several farmers, hundreds of farmers. Then I also have to mention about biofilters, bioflag technology. This is already bioflag, RAs I mentioned. Then biofilters has to be used various types of, maybe I think come again also I'll mention there. And algae based system contribute to sustainable water treatments. Water sustainable water, that is very important. The biotechnologies in conserving endangered species through two ways. One is cryopreservation of genetic material, then artificial propagation of threatened species. Cryopreservation of gametes, mainly, the sperms are cryopreserved, but cryopreservation of eggs is a little difficult, and so the can be preserved for several years and can be used. Okay, particularly in case of endangered species or threatened species. So that's the one thing. Then artificial propagation of also threatened species, then endangered species, because we expect that later the species may be extinct, but still we can produce the fish if we have the gametes, preserved gametes. That is the concept here. Yeah, this is also another extension education activity. And this is the very maintained good farm with paddleable aerators and it's a shrimp farm. And then another area I would like to stress upon is cage culture. Cage culture has been very popular in the recent years in the country. And earlier, of course, maybe in about 2 decades back, we are not, thought about any cage culture in the country in that in that magnitude. But these cases, we used to see way back. Probably I was there in Scotland in 1993. There I visited, these Norway, Scotland, and various marine sturdy cages. Huge cages for in the seas and oceans, coastal areas. And I was surprised to see so much of various species: salmon, sea bass, sea bream, turbot. Species were cultured in the huge, very sturdy cages. But that time, of course, in India, we didn't have any that much of cage culture. But then I was thinking that when probably will this scenario we can see in India. But of course, in the recent years, we have been able to achieve that in the country. The first, of course, earlier there was freshwater aquaculture cages were used in reservoirs, especially major tanks reservoirs were used. Also, for example, one we had in Karnataka, Krishnarajasagar KRS reservoir in early say 90s. They used Nile tilapia, then Pangasius and other species in the freshwater cages, whereas marine cages have come in the recent years. Uh, so that especially these marine cages, cage culture in coastal aqua, I can say coastal areas have been very popularized by the Central Marine Fisheries Research CMFRI. Cochin, of course, I am present sitting member of the research advisory committee CMFRI. I know the work they have done tremendous work, and that has been helped to develop this cage culture all along the east and west coast. We see now huge cases, and still tremendous scope is there to expand this activity. Cost expensive cages have to be used, sturdy cages, because in seawater these are likely to be corroded, and so you need a sturdy anti-corrosive type of cages. You can see here, this is a beautiful, so many cages are installed. Then we have automated system process expansion of cages. uh, Water quality and so a lot of advancements have been done, how to monitor, how to measure, due to automated system, probes and sensors are available, and real-time techniques have been developed. Automated system process in the data collected by sensor on a real-time basis. This information is crucial for farmers to monitor the environmental conditions within aquaculture toxic, ammonia and nitrate. There should be less, very, very less, minimum. And otherwise, fish, will be killed if there is a shear toxicity. Then the informed decisions regarding the water quality management, feed schedules, and disease preventing strategies. So all these, the data, analytical data will help the farmer not only meet the water quality but also feed management. So that will be very useful. And we also have automatic feeders. In the feeding, automatic feeders are used in organized another is called the demand feeders. The time feeders actually they deliver the feed at periodic time, say half an hour this much or 1 hour this much feed automatically. Whether fish will eat or not, that feed will go to the pot. Where another category of demand feeders, these demand feeder deliver the feed depending on the requirement by the fish. For example, fish. So when he's hungry, there will be a pendulum one so inside the water. So they will touch and hit the pendulum, the fish. Then some feed will fall down. That means the fish they're acclimatized, used. It knows that if it touches that, oscillates the pendulum, feed will fall. So like that, so the feed will require quantity of feed will be released, and when the fish are hungry. So that is they are called demand feeders. And these cages I was mentioning about sardine marine cage. You see, these are simple, cost-effective cages fabricated by my students here at Meerut University. With minimizing waste and optimizing growth. Now, advanced algorithms analyze data, feed I think this is the photograph taken in Nellore, where the huge farms. One pond, maybe 5 hectares, 6 breeding program. I also mentioned earlier briefly selective breeding program, and here I would like to mention the work done in India. Central Institute of Freshwater Aquaculture, Bhubaneswar, and ICR Institute, Premier Institute. Wonderful work on genetic improvement, particularly Jayanti Rohu, that has been developed through selective breeding program. Jayanti Rohu and the Scampi, genetically improved Scampi, then Katla, genetically improved Katla. All the three species, the work done by the CIFA Bhubaneswar. Then earlier to that, we have gift tilapia. Gift tilapia is also and in fact, what is gift? Genetically improved farm tilapia that is developed by the World Fish Center in Malaysia. It was earlier known as Iclarum. Now, later they redesignated the institute as World Fish Center. It is an international intergovernmental organization. So they have also done a lot of work on aquaculture and fisheries various aspects. So these are the genetic improvement species. So that's why we need also, because I mentioned earlier, genetic depression. Now what happens, when you use the same stock, for example, in a pond, they say one farmer is having some ponds for 10, 15 ponds. They're using the same. He's producing the seed and he's culturing. Again, same thing he is using as a brood stock. So that where the genetic depression or the genetic vigor will be lost. So that means that they start, very poor growth, and also they will be more susceptible for diseases and pathogens. So, in order to avoid this, you have to improve the genetic vigor. In other words, to reduce the genetic vigor, you have to bring the stocks from other areas. So, from other farm, especially the riverine stocks, where natural, stocks will be there, and that type of stocks are very good pure stocks. The strains are used especially as parents when they are doing the normally the genetic improvement through selective breeding program. So that's the one thing. Then marker assisted breeding. This marker assisted breeding involves using genetic markers linked to target traits. So that's another way. This allows for the rapid selection of individuals with the desired genetic characteristics, okay, accelerating the breeding process. So this is another way. Then you can see is the freshwater prawn, scampi. In fact, I worked a lot on this species at Mangalore earlier. So especially is developing feeds and then a cost-effective feeds. Then we have hatchery production. Then artemia as a efficient nutrition manipulation of artemia, nutritional manipulation artemia for the larvae of freshwater prawn. So that was the one my favorite species. In addition to, of course, carps and shrimps, what we worked. Then recirculator, I have already mentioned briefly RAS, recirculators. The same water is reused in the sense where there is a scarcity of water. This is the technique, very technique. This can be employed in the indoor system also, because the water, after passing from the culture tank where fish or shellfish are there, so then it goes to some different filtration like mechanical filter. Among the mechanical, we have normally cartridge filter, then sand filters, like that. So these are mechanical filters mainly to remove the suspended particles, okay, solid particles. Then the other that only suspended is removed, but we are not going to remove the toxic gases like ammonia and all. So that is taken care by the biological filtration, where biological filtration removes the all the toxic nitrate, ammonia, and other things. This mainly works on the principle of microbes. These microbes convert, various nitrosomonas, nitrobacter. All these are so the uh, involved in the degradation of ammonia into harmless nitrate. So that's what happens in the biological filtration. So these are especially RAS is equipped with mechanical and series of biofilters, and water is recirculated and flown back to the tank, culture tank. That is the system. Okay. So you can say this is, of course, this is aquaponic, but here also you can see the biofilters, some filters are connected here. So the water here in the, of course, this is this RAS not necessarily required to filter the water. So it can be filtered by the mechanical filters also. So that is the water and nutrients for their growth. So yeah, so coming back to the aquaponics, there is another recent development in aquaculture is the now, plant synthesis normally we use all the vegetables, especially the broccoli, then leafy vegetables, tomato, etc., can be grown without any soil base. Actually here normally the traditional cultivation of this vegetable used in the soil based land system, but here without any soil, just water. Okay, so you can see here, so very organized way of doing the aquaponics. And so the water from these below there will be a tanks wherein fish, any kind of fish, I can use your tilapia, common carp, any other fish. Normally it's a resistant type of fish, hardy fishes are used because these small tanks you cannot use delicate species of fish. Then this water urban areas, even in the rooftops of
Jai, I think there is another network connectivity issue with sir. So sir is joining within 5 minutes. So please wait for the same.
and I'm reconnecting it.
Sir, your voice is clear. Please share your slide. Sir, please share your slide by going to clicking on the present and then slide. Jai, sir, am I audible to you? I think there is a network connectivity issue.
Chinese wanami is the species that has been popularly cultured very on a huge scale. But in the recent years, it is
Sir, sir, sorry.
white-legged shrimp or wanami is cultured very popularly in the country. And in fact, to say something about the shrimp culture. Actually, the shrimp culture was a huge success, and it is because this tiger.
Sir, your slide is not visible. Sir, please share. I think sir is facing some network related issues. Please wait.
Include it, no problem. I've taken the sufficient time. Uh, so, yeah, but here somehow the slides are not showing. Ah, okay. Luckily, it's come. Just I'll just sum up. I think I'll go to the end of the talk.
Yes,
And
sir. It's now visible.
yeah, yeah. The once it disconnected means it starts from afresh. Yeah, so here I can see some smart farming technologies, Internet of Things devices, like various sensor actuators and drones. So drones are used for various equipped with cameras and sensors to provide aerial surveillance, especially in large scale aquaculture, to assess the overall health of aquaculture ponds, to detect the irregularities and optimize resource management. Because in organized big farm, difficult to manually monitor. So now advanced system using the drones and all. So only in very well organized, very systematic maintained farms. Then, effect of climate change and aquaculture. There is another way. Climate change. Every people are talk about the climate change and global warming in the recent years. That's also have effect on the aquaculture. Usually due to the global warming created by El Nino phenomena. That is probably people are aware. El Nino phenomena. It is actually it is one of the factors changing the climate and the global warming worldwide, and subsequent to climate changes, adverse effects on various other aspects, and also aquaculture species. And mainly delicate species including endangered and threatened species will experience deleterious effects because of the climate change. Then reproduction capacity and survival of delicate larvae will be affected. Then dedicated efforts to mitigate the climate change on species and biodiversity needs to be undertaken. And especially this, when you think of endangered species, threatened species, especially this is very important, the climate change. And so we have to safeguard, conserve our valuable fauna and flora. So here, of course, these are some sort of floating cages. You can see here how it is done. And this is the hatchery setup, circular eco carp hatchery established in our university here at Meerut University campus, and used for breeding of the carps. And so, of course, in conclusion, I can say these advancements in aquaculture and biotechnology collectively contribute to the evolution of aquaculture into high-tech, more efficient, sustainable, technology sound, and advanced industry. Developments in these areas, exploring and applying the innovations and modern tools can significantly enhance the aquaculture productivity and environmental sustainability of aquaculture practices in the long run. Okay, this is in a nutshell what I have been discussed. And here some just I just glanced through some photos. This is a cutla. Indian major carps. So this is, I think, rohu. Then we have grass carp, silver carp, and common carp, and then big head. This is of course Chinese carp. It's not much available in India, but China. And for those who are not very familiar, just I want to show these photographs. And this is the milkfish, Chanos chanus, then is the tilapia. Uh, and the species. Then this is the exotic salmon, a culture very popularly in European waters, Europe, North America, and everywhere in the marine system. And this is the freshwater prawns, scampi, what I discussed earlier, cultured in freshwaters. It's also cultured popularly in India as well. Then, yeah, of course, these are some photographs taken in, I think, Bhimavaram area where I visited some time back. And you see, huge quantity of Pungaceous catfish is cultured. And, several trucks in front of me were loaded and transported. This is the other thing. Then this is another species called Rupchan, or also known as Paku, is very popularly cultured in freshwater, and it looks like a pomfret, marine pomfret. People call it freshwater pomfret. Okay, so this is also another species very much liked by the consumers. Okay, so these, I think, with these, actually I have taken sufficient time. I conclude my talk here, and I take this opportunity to thank Dr. Nisha Rana for giving me an opportunity to address this seminar through a keynote address. Then thank you all, the participants, for your patient listening. Thank you.
Thank you, Professor Murthy, for such
Yes.
Professor Murthy for such an illustrative, informative, and cognizant speech. Thank you so much, sir, for joining us.
Mhm. Okay.
Now,
Okay. Thank you. Okay.
now I would like to invite Professor Dilip Kumar Jha, Head Department of Aquaculture, Faculty of Animal Sciences, Veterinary Sciences and Fisheries, Agriculture and Forestry University, Chitwan, Nepal, to address the gathering. Professor Dilip Jha. Hmm? Sir, your voice is not clear to us. Sir, you are not audible. Sir, you are not audible to us. Hmm. I think there is some technical issue with sir. So for this session, I'm going to start the next technical session. For this session, I would like to introduce our second speaker, Professor S.N. Love. Professor S.N. Love is a distinguished speaker, scholars, senior researcher, and an eminent professor renowned for his exceptional contribution to the field of life science, fisheries, and aquaculture, with a focus of animal nutrition. With an illustration of career spanning over 4 decades, Professor S.N. Love has earned his master in Raleigh 1984, specialization in aquaculture, and joined as a faculty of zoology at Tribhuvan University, Kathmandu, Nepal. Sir was awarded SARC Fellowship in 2022 and 2012 and obtained his doctoral in philosophy in aquaculture and nutrition from the University of Delhi, India. His commitment to research led him to undertake a postdoctoral research position at ICR Central Institute of Fisheries Education, SHIFI, in Mumbai, under NAST INSA Fellowship in 2015. Moreover, he was honored with the Fulbright Research Scholarship in 2019 and completed his senior level research work in nutrigenomics from the world-renowned Aquaculture Research Institute (ARI) at the University of Idaho, Moscow, USA. He is a founder president of Nepal Aquaculture Society patron of Asian Biological Research Foundation and fellow of Linnean Society of London, and ornamental with a grade gold medal as a Nepal Vidya Bhushan by President of Nepal, Dr. Varan Yadav. He has also received Dr. V.R.P. Sinha Gold Medal in 2016 from ZSI with Davangere University, Karnataka. Professor Love currently holds the position in CEO at NTP Group of and currently serves as principal of NTP colleges. Professor S. N. Love has made significant advancement in biology, biochemistry, and physiology, particularly in the area of health science, nutrition, animal development, feeding technology, hematology, tissue infrastructure, stress biology, immunology, and genome sciences. Now, I would like to invite Professor S. N. Love to deliver his talk.
Thank you, Dr. Nisa. Just let me, I want to know that how should I start my uh, slide?
Okay, sir. Sir, you can go to the present below the screen.
Upload the file.
Present and then slide and your computer. After that, you can upload your file. So you
It
can go
will
on
take
present.
time to upload to process. It will take time.
Okay, sir. Okay, sir. No issue.
It is processing. So,
Okay.
uh, may I know what type of audience are here because I'm totally one way and
Yes, sir. There are researchers, UG student, PG student, PhD scholars, and few scientists, faculty members, and fisheries farmers and aquaculturists. Majority of our students and faculty members.
okay. So first of all, uh, say my namaste to all of you, and especially I thank you, Dr. Nisa, gave me this opportunity, and just I'm being here to share my experience among all my friends and audience. So again, this is the wonderful program organized by mm, Swami Vivekanand Subharti University as an online international workshop on recent advances in aquaculture and fisheries science. So my topic, what I had given, black soldier fly larvae, which is the new vista for bio-waste management and animal feed ingredients for aquaculture. Am I audible to everyone?
Yes, sir. You are audible, and also your screen is also visible.
Am I audible?
Yes, sir. You are audible.
Okay. So first of all, I want to concentrate all of you that we are totally based on food because our health is conscious and the food is essential for energy, and energy is needed to develop and to stabilize our metabolism and especially the body growth. So food production, there are two methods, two systems. When food production is on land, then we use the term agriculture, and when food production is in water, then we say it is aquaculture. So aquaculture is one of the fastest emerging food producing sector in the world, and it plays a significant role in the world economy. According to FAO, aquaculture and fisheries are responsible for supplying 17% of the total animal protein globally for the human consumption. So, dear friend, I'm going to share the aquaculture, which is also called blue farming. So, what is the present situation and what will be the future of this blue farming in the coming day? So we can see this chart, the world population. The world population these days, nowadays, it is 8 billion and it is now growing to in future, nearly future is 10 billion and in 2030 and you can say in 21. So it is 11,000 billion. So 11 billion is another challenging that every day the population of the world is growing, and once the population is growing we need the food. So the in the terms of aquaculture we can see this chart that the aquaculture production is growing gradually day by day, while the capture fisheries, which in the previous lecture we can see that the we are India is totally based on the most of them are basically on the capture fisheries, because without the capture fisheries the aquaculture production is not possible. We need food for the aquaculture. So food for the aquaculture is directly based on the capture fisheries. So food is concerned that for the livelihood there are two major problems. The first, the growing human population continues to contribute the increased food demand. As the population grow, the demand of the food also increase. And so then for the to provide the animal protein, healthy feed, healthy fish production and food stock for the livelihood are the key component of biodiversity in the ecosystem. So there are another, the first is the production of food, and that is parallel to the production of the continued growth of the animal. So now the first production is the another problem is the production of bio waste. As we use the food, the production of bio waste is also, and the crisis of the animal protein. So as we utilize the fish, capture fish in the food, then the production rate is gradually decreasing. That's why there is the crisis of the animal protein. So there are two major problems I am going to focus. First is the bio waste, and second is the crisis of animal protein. So what will be the future of the animal protein? That is the major question. How will we get if the gradual day in after 10 years, 20 years, 50 years, if the another millennium, if there is no production of the fish or capture fish, then what will be the other source? What will be the other source of animal protein to enhance the aquaculture or aquatic farming? So then the another source or possible source are for the animal protein are the fish meal, blood meal, bone meal, and insect meal. Because those animals who are carnivorous, they need animal protein. And these are the major problem faced by the fish farmer in terms of the lack of land, lack of capital, high interest rate, lack of improved fish species, lack of market, high price of the food. Because if we are not getting food locally and if we just busy in the import of the food, then the definitely cost of the food increased. So what we need, the policy planning and practices, policy to practice is the most important part of the country, and everyone should be conscious regarding the production of the capture fisheries and their policy planning. Another question is related to the bio waste. So bio waste is the day by day problem, because when we consume the food, the waste definitely develop, increase, and the bio waste is another problem. So what is the, how will we solve the bio waste in the society, in the environment? So this is another challenging problem. We can see what is the status of the bio waste every day in our surrounding. So this bio waste, what will be the solution of the bio waste? That is one of the solution is, in my research, in my study, we have found the black soldier fly is the new vista for bio waste management. Remember, so how this black soldier fly? It is an insect which are going to be the next revolutionary solution for the food and feed crisis of the world, because its larva contains 40% protein like the fish protein. So when we introduce this fly to the organic waste, then they start their life cycle and they start feeding on the organic waste. And there is the utilization of organic waste, and the production of the larva is same side by side. So black soldier fly have proven to convert the organic waste into high quality nutrient for pet foods, fish and poultry feeds, as well as residue fertilizer for soil amendment. So black soldier fly larvae is the main source of animal feed ingredient for aquaculture in the coming future. So why black soldier fly we need? So it is rich in protein, high value for free source, and it is easily available. It is not the disease carrier, and larvae contains natural antibiotic and omega-3 fatty acid, essential amino acid. Also, all these are here. So when we go to the life cycle of this black soldier fly, so life cycle of black soldier fly is completed within 10 to 15 days, and there are different stages of this, and we can see that this chart that indicate the way this, when we utilize this black soldier fly on the bio waste or organic waste, or you can say the utilized food waste, then it start feeding and rearing its life cycle, and after the rearing its life cycle, then fertilization and manure is products. There are three things at the end of the product is the the larvae. The larvae, when we crush the larvae, we will get the three different things. The one is the animal protein, and another is the BSFL, black soldier fly oil, and the remains of this is called frass, which will be utilized in the manure. So if we 100 kg of this organic waste will be utilized in this process, then 3.5 kg fat, 5 kg animal protein, and 20 kg frass can be produced. So black soldier fly larvae is definitely the alternate source of feed in the aquaculture. So after this study, I visited the University of Idaho and started one experiment. That is, the name of experiment was expression and lysis. Expression means gene expression, and lysis of some immune-related genes in rainbow trout fed black soldier fly. So this was my research station and the team. And the aquaculture, this rainbow trout is always found in the cold water, and we developed the feed by the supplementation of this black soldier fly larvae powder, and in the indoor aquatic ecosystem culture system we started, and there are four different types of measurement we have finished. One was the weight management to study the growth profile. Another was the blood and hematology to study the physiological or hematological. Another was the blood plasma to study the biochemical profile, and the last one was the gene study. So after the use of all these instruments, the complete blood profile was found normal, biochemical performance was found very good as compared to the other, and expression analysis of the growth gene was also found good. Immune related gene was also good, excellent on the immunoglobin. And in conclusion, the study provided new data and knowledge on the potential use of new sustainable feedstuffs for carnivorous fish diets. The main finding indicates that the dietary fish meal can be replaced by the partially black soldier fly larvae meal. Up to 50% is sufficient to understand the proper aquaculture. So with this regard, we have published few papers in this concern in different journals. You can see there are some publication that is given, and then this our the information we have submitted to the World Aquaculture Conference during 2020 at Honolulu, Hawaii. And I am just I cannot leave the acknowledgement of some of the professors to whom I received the excellent information in my career, that is Professor Konrad Dabrowski, Professor Dalbert Gatlin, Professor Brian Small, and Professor Ronald Hardy. And now, after this, coming to the point, as I'm a president of Nepal Aquaculture Society, so I have to share something about what is the status of aquaculture in Nepal. So we can say, friend, that the Nepal is very close, three-side bounded, connected with the linked with the India, and one side from the north is China. And the fisheries and aquaculture started, although it is in the very ancient time, because in our Veda, the fisheries is concerned, the fish is the first incarnation of Lord Vishnu, but in Nepal, the entry of the common carp is started in 1949 to 1950, and entry of major carp means the Rahu, Katla, all these are in 1960, and the major carp, after the major carp, the integrated fish farming started in 1968, and the private hatchery farm start in 1989-90, and the trout introduction of trout was in the 2000 or 1999, you can say. And trout farming, rainbow trout is the very common, and we have our own research lab and outdoor station to just produce the rainbow trout in the cold climate area. So we can say that the total production in 2022 was the 81,000 metric ton, and there are so many societies who are busy giving the information or sharing the value in the country, that the Tribhuvan University, Kathmandu University, Nepal Fisheries Society, Nepal Aquaculture Society, and Agriculture and Forest University, and so many privates. So there are, we can say, 67% male and 60% females are busy in aquaculture and fisheries. And you can say there are so many contributions. The country, the natural resources are very rich. We can say the world Second largest country is Nepal in terms of water resources, and there are so many coverage area of the river, streams, lakes, reservoirs, ponds, marginal swamps, integrated paddy fields, irrigation canals, and so many ways, and they cover and they are suitable for the freshwater aquaculture. So there are commercially important fish are altogether around 7 to 10. That is the you can go in anywhere in the market, you will get rahu, naini, katla, common carp, silver carp, big head, grass carp, rainbow trout, pangas, and tilapia. So concerning the record of the fish and fisheries in Nepal, there are 15 endemic fishes and 15 exotic fishes. 34 fish species are in the red list announced by the IUCN, and it is total 252 fish species are found in the country. Out of that, 236 are indigenous and others are exotic and useful for the species. So now the most of the fish, as I told you, rohu, bhaku, big head, common carp, naini, silver carp, and grass carp. So there the highest production is we can see 27.616 production, 27.16 production is rohu, and the lowest production is the grass carp, that is 15.94. So again, now there are three different area in the country, that the Himalayan area, mountain hilly area, and the Tarai area, which is called Madhes. So Madhes is the plain area which is directly connected to the Indo-Nepal border, and we can see this chart that the largest production of the fish is in the Madhes area, and due to the good climate condition, and there are so many production system and how it reaches to the market, that from the farms to the consumer, there are the mechanism that the wholesaler, local dealer, and the agents and commission agents, the government scenario, and all these finally reach to the consumer. So now there is no any standard policy that I would like to share, that the cost of the production of the fish and how the consumer is getting in what cost should be in such a way that the food should be very cheap and comfortable. So the storage mechanism is there is no storage, 53.84% is no storage system, 38.47% is now the storing in the ice, and 7.69% storing just in the refrigerator. So again, the transportation system is also, they use the bicycle, motorbike, and pickup van. Now we can say the packaging materials used for the fish is the plastic, aluminum, and different ways. We can see that the silver carp, common carp, grass carp, all these in terms of their the cost value, what is the cost in the market of which fish, which is very common. So mostly 250 rupees per kg is the very standard. And now the major problems in aquaculture, I told you that the feed is the most important part, and to minimize the feed, so I would again at the end, I would like to thank the chief patron of this Swami Vivekanand Subharti University, and other dignitaries and top level chairpersons, vice chancellors, and all that. And at the end, Dr. Nisa, who gave me the opportunity, and I thank you all of you that you have listened my speech. And I conclude that at the end that 10 minutes, 5 to 10 minutes, I would like to share the interaction from the audience, that if any question is coming from the audience, it will be glad to share, so that it will be the two-way learning, two-way interaction. So I would like to request Dr. Nisa to communicate and share the, if any question is from the audience, then I would love to answer all these.
Okay, sir. If there is any question, those can drop in chat box or they can ask. So if no one is asking, then I would like to thanks to you, sir, for such a enlightening, evocating, edifying lecture. It will be definitely help us in future and very helpful for all researchers. Thank you so much, sir, for joining us and enlightening our audience.
Thank you. So, with this speech, I want to leave the studio, the program, and I have to join another program. So, thank you very much and namaste, all of you.
Thank you so much, sir. Namaste, sir. Now we are going to start the next technical session. For this session, I would like to invite Dr. Sachin Kumar Shandilya, sir. Dr. Sachin Kumar Shandilya is Assistant Professor in Animal Husbandry and Dairy Sciences in CCS College, Machra, CCS University, Meerut. Sir has also completed his UG in 2009, BVSC AH Pantnagar University, Pantnagar, MVSC by through ICR NDRI Karnal in 2022, PGDAW from IGNU. He also served as District Training and Block Development Officer, Department of Rural Development, Government of Uttar Pradesh, Veterinary Officer PVS at Government of Uttarakhand. His research area of specializations are livestock production and management, animal welfare, dairy science, organic livestock farming, integrated livestock farming, rural development, and extension. Sir is also a member of scientific societies, life member of Indian Society of Animal Production and Management, life member of Society of Conservation of Domestic Animal Biodiversity, life member of Agriculture Technology Development Society, and registered member of UPVC and registered veterinary practitioner, Veterinary Council of India. Sir has received many awards, including Best Presentation Award, Excellency in Teaching Award. Sir has delivered many talks, including live video lecture for National Institute of Open Schooling, PM Vidya Channel, radio talk broadcasting on Prasar Bharati, AIR Delhi, in the Press Channel, in program Gram Sansar, in program Krishi Jagat also. He also served as Block Development Officer, Block Nota District Saharanpur, co-in charge in three-tier Panchayat election 2015, Block Development Officer, Block Agota, District Bulandshahr, District Training Officer with Drawing and Distribution Officer, District Institute of Rural Development, Bareilly, Block Development Officer, Block Bajipur, District Bareilly. Now, I would like to invite our speaker, Dr. Sachin Kumar Shandilya, sir. Sir, please.
Thank you so much. Thank you so much, Dr. Nisha ji. First of all, a very good morning to all the dignitaries, all the participants who are listening and participating in the international e-workshop on the recent advances in aquaculture and fisheries sciences. This this conference, this workshop is in the under the this SDG goal of 14 goal means life below water, and we all know that now the sustainability of the any technology or sustainability with any new research is very important because all the techniques, all the new innovations, if don't have the sustainability, they will not give the proper environmental care. They will not have the proper environmental care for long period. So it is very important for us as we are developing countries. In India also, we have a large population, and there is a very big and huge problem of the fulfill of the nutritional requirement of this large population. Particularly the malnutrition, the problem of malnutrition is very huge level in our country also, and in other developing countries also we are facing. And we all know that our land capacity, land holdings of farmers is continuously decreasing exponentially. We are making the concrete jungle, concrete forest, and we will not have the proper land for the cultivation of crops and other agricultural enterprises. Excuse me. Uh, so, for taking this in concern, we have this in this recent advances in aquaculture and fisheries sciences. The topic was this integrated fish farming. It is a very important tool. Integrated fish farming will be very important for fulfilling the this malnutrition problem of the our population, and in this all the world population which is increasing. And before I before myself, there's many dignitaries, very renowned dignitaries have focused on this problem also, that we will have this a large population in future, and there will be lack of cultivated land, and also the food problem will be there. So this integration of this, particularly the fish farming, integration of fish farming is very lucrative and very important tool for this competing this malnutrition, and particularly the protein problem, protein deficiency problems of the huge population in women and children and kids of our country, and international in world level also. This is a very means this is a problem of this malnutrition problem is also there in this many developing countries, and also our country also. This is particularly the what is the this is means of integrated fish farming, IFF. The integrated fish farming means the integration of fish farming with the agriculture or allied enterprises. The type of farming of this type of farming, when we integrate the fish farming with the other agricultural enterprises, is called the integrated fish farming. And this fish farming may be integrated with the this rice paddy fields, with livestock and other horticultural crops also. Particularly in livestock sector, this duck rearing or duck husbandry is very good and very fit for this integration with the this fish farming or aquaculture. You know, it's a very unique type of this integration which improve the income of the farmers, and different type of crops simultaneously. If we grow, then we get the more income, and the population, rural population of our country, rural farmers, and particularly the small and marginal farmer will have the good income source if you go if they go for the integration of this fish with the other livestock and agricultural farming enterprises, because fish is a very cheap protein source, I have told. So it will improve this malnutrition, and this is the main focus of our country. The government is there to improve the this malnutrition problem, to meet out this malnutrition problem. So the this integration will improve the income, will improve the this protein source, protein food will improve, and increase the productivity of the both of the enterprises. So the this we will go in this content in future in the slides, through the slides, introduction and principle of what are the principle of IFF, integration fish farming, and what will be the scope of this IFF, particularly at which area and which this states in India and in other countries also. This will be applicable. This will be applicable properly, and for the farmers will get the more benefit we will go through this. And this is the main focus will be the types of IFF, integrated fish farming. How many types of integrated fish farmings are there? We will go through this. And now again, the advantages, the main advantage is the focus of this integration fish farming will go through this today's workshop. And after that, the conclusion. So the basic principle of the IFF is the concept. It is based on the concept that there should be no waste. We have no scope to waste the products or byproducts of any type of farming. It may be the agricultural crops, or it may be the horticultural crops, or it may be the livestock enterprises. So because we have the scope of all these products and byproducts, scope to consume and to develop this type of animal feed or other type of important nutritional these things by the help of the byproducts or waste products of the different type of agricultural this enterprises. The fish utilize the animal and agricultural waste directly or indirectly in case of integrated farming, because the fish takes sometimes the excreta of the livestock, and this sometimes the paddy, this field of this weeds are there in paddy fields. So this fish, if we integrate this fish with this paddy fields or rice farming, this weeds problem will be meet out, and the fish will get the nutrient from these weeds. And the livestock sector also, if we integrate the livestock farming with this fish farming, then the excreta of livestock and the waste product, particularly the feed particles from this poultry, the duck husbandry, and this chicken farming, and this pig farming, this feed particles which are left out in this farming system, and the excreta which have to manage for manure and other things, these are utilized by the fishes very efficiently. And these are very nutrient also, particularly the nitrogen and phosphorus content are very rich in livestock excreta. So this is the main focus, that there should be no waste of this byproduct or product of any type of agriculture enterprises. So it is considered that economic and efficient means of environment management, that I have told that this is the sustainable. This is very sustainable type of integration of the farming system, in which this both of the this farming both of the farming enterprise will get the benefit. What are the scope? What will be the scope of IFF? As I told, that it is an important ecological balance, sustainable technology, because this is the main focus of this. Those UNO has declared the 17 SDG, Sustainable Development Goals. This sustainable is very important. This is the because of many researches, many type of new innovative technologies have been outdated due to this technology was not sustained with the environment particularly, and thus have to abolish from this our society, because we have to conserve our environment. Otherwise, nothing will be there. No use of the technology if you not go for the sustainable technology. So in ecosystem with no waste is integrated will work. This food supply will increase as both of the enterprise will go and flourish simultaneously. The employment will be more, employment generation will be more. So decrease the environmental impact. As I have told, this is the main focus, the sustainability of the environment, because many times our this huge paddy fields and our huge population of livestock are claimed to uh, contaminate or to this climate changes. So for this also, this environmental impact is this is the very important thing. That environmental impact is decrease. Environmental impact is very improve if we go for the integration. The economic benefits are also there. This farmer will get the more income if the farmer will go to the integration. This now the what are the types? What are the major types of fish farming integrated fish farming? This is the main. There are two types of major fish farming integration. Either it will be with the integration with the agricultural crop, or it may be with the livestock farming. In agricultural crop, it may be the paddy fields, particularly the main focus is on the paddy fields. With the paddy fields, because this paddy plant need lot of water, and some varieties of this rice of paddy grown in this is flooded water also. So it is a boon for this fish farming with the paddy field. And same thing is there in livestock farming. If we go for the livestock farming integration with the fish farming, it will improve, as I told, that it will improve the fish farming also, and also improve the this is less labor requirement for the livestock management, or the poultry, maybe livestock, maybe poultry, or this cattle or pig, anything. So these four type of major livestock fish farming integration are there. The major is the duck cum fish integrated farming. Second one is the chicken cum fish integrated farming, pig cum fish integrated farming, and same thing is the dairy cum fish integrated farming. Many times the cattle is also integrated with the fish farming. The farmer who have this livestock as a source of income, and both of the this cattle and fish, they sometimes have, particularly in our coastal areas, or the areas where the this water availability is very good. There these ponds are available, and this aquaculture and fisheries are the major this enterprise, major agricultural or farm enterprise for our farmers. And farmer also this rear this duck, chicken, pig, and cattle also, and also have this field of paddy. So this is the major. The principle of this integration. If we this the farmer is reared, farmer reared used to rear this livestock. It will be ruminants, pig or poultry, anything, and the feed crop co-products get from the plant production. Plants maybe the fodder, or maybe the horticultural crops, or maybe the this is cereal crops or anything. These byproduct or co-products fed by the this is offered to the ruminants or pig or poultry, and these sometimes this manure in the form of excreta, dung, or droppings of the poultry are the waste product having the lot of nitrogen and phosphorus content. These are this mixed, these are allowed to go into the pond where the fish are reared, or the aquaculture is practices is there. And this livestock waste, this is excreta, or this splint, this particle, feed particles also. Sometimes this many time of this type of this some feed this feed leftover feed also, these may be allowed to in the pond, and this fish get these particles, feed particles in excreta, and flourish very good manner. This is the integration of fish farming with the agricultural farm. A very good picture of paddy field having this fish farming. Rice cum fish culture is there, and we can see we are in the on the slide. We can see that in the water, in the this flooded water, the fish are flushing very good manner, and paddy fields are also there. This rice cum fish culture may be of basically two type. These may be simultaneous fish cum rice culture, and it may be the rotational. We will go through this. In the simultaneous, this is the picture of simultaneous rice cum fish culture. The both of the farming, the fish farming and the paddy farming, are flourishing in simultaneous manner. And sometimes farmer go in the rotational rice cum fish culture, where the this is this uh, paddy crops is when the paddy crops is harvested, then this fish, the pond, the water will low, and the fish will this allowed to flourish. Which the fish seeds will this seeds, fish seeds with seed, and the farmer will get the income. This is a very good picture. This aquaculture with integration of paddy cultivation. This was started first time in Japan, when the troll fisheries was there. This sir has told previously from my this speaking. The sir has told that Japan, when this 1980s, this due to the climate change, this prawn fisheries were banned. The troll was this cone type nets, which was used to take the caught the fish from the deep sea. So in the Japan, it was started firstly, and in India, it is very good scope of this integrated fish farming in the states of Assam, particularly West Bengal, Kerala, Tamil Nadu, and Odisha, where there is a very good amount of water is present during cultivation. So this is the advantages. What are the advantages of this rice fish culture? If you go for the paddy field with the fish culture, this is the economical utilization of land. That both of the we have seen the both of the crops. This farmer has got the economical utilization of land. The land is used for paddy field also for paddy farming, and also same time this fish farming is growing. A little labor is taking, because both of the extra labor is reduced, because very this if you go for the separate business, this fish farming and another is the paddy farming, the labor will go out in the field, and the labor has to do extra work. But here both of the crops and grow simultaneously, so there is a cut out in the labor. Saving on the labor cost toward weeding and supplementing feed, because the fish many of the fish, common carp and grass carp particularly, this weed out this is sometimes weeds are there in the this paddy fields, so they are weed out. These crops are used. These fish crops are used for this weeding of the weeds grown in the paddy fields. Rice is also enhanced, because this is the raking of the this water, and this is the also raking of the this soil also, and this excreta of the fishes used for the paddy field as fertilizer. So there is an enhanced rice yield if farmer will go to the integration with this fish farming with the paddy field. There is this additional income through diversified harvest of rice and fish from water and other crops, uh, from the burns and dye of this pond. The important thing is this: the the important thing is this, that rice variety and features should be the particular rice variety should be used, because it should be this sustained in the this type of this type of flooded water, and also have the sustain that their root should be strong. This type of these are the varieties: ADT6, ADT7, Raja Rajan, and Patambi 15 and 16 are suitable and have been proved for good for the fish farming. These varieties have very good this root strength, very good root strength are there, and also have the very good growing stage in the flooded water. And also, this is important point. This rice variety should take 180 to 200 days lifespan, because fish culture uh, can culture for 4 to 5 months tenure. If we use this short day lifespan variety, it will not suitable for the fish farming. So there are if we go to the focus, the rice variety should have the excuse me should have three qualities. First thing, the ability to grow in the flooded water, and second thing is the strong root strength, and third one is the this lifespan. 180 to 200 days lifespan should be there of this rice plants. So these three varieties, these three peculiar characteristics should be there for integration with the fish farming of this paddy crop. What are this about this fish is talking? This fish should be capable. Excuse me. Fish should be capable of tolerating shallow water, because there is no deep water, because paddy crops are growing, so there is no deep water. So the fish should be able to tolerate shallow water and high temperature, because this paddy fields paddy plants this paddy plants this grow this methane and other gas CO2 production, and low DO level at high turbidity. This is the characteristic for fish stocking. It should have the shallow water tolerating ability, high temperature, DO level. This dissolved oxygen level should be in less dissolved oxygen level. It should be survived, and feed cease stock generally June to August, because the advantage of this rainy season particularly will get. The Indian major crops, this Lobia bata, Anabas species, morel, catfish, mugil, tilapia, etc., can be stocked with the integration of the this paddy fields. These are the two types. This, if you go for the rice cum fish integration, the simultaneous culture, we have seen the photograph of that simultaneous culture, where both this farming system are growing simultaneous, and another one is the rotational. This is the very good photograph on the left side of the screen. This is the perimeter type. Perimeter on the periphery of the paddy field, this rice field, this fish production is taking. Fish farming is done. And in another page, this is the central pond type of simultaneous system. In this, thus in the center of the paddy field, this fish pond is growing. This fish pond is there. And third one is the lateral trench type. In between this water, this water, this water flowing, this bank are there. In these water trench, this fish farming are taken. Fish crop is taken from this along with this rice field. Now, what are the advantages if we go for the simultaneous rice fish culture? I have also have we have discussed this fish increase the rice yield because it is chiefly due to the indirect organic fertilizer, so the fish excreta, and also control unwanted filamentous algae and unwanted weeds also. So this is the advantage for the paddy fields, and insects like this sometimes pests like stem borer which can control by morels and catfishes. It is another and add for this advantage is this sometimes the stem borers or pests, some pests are also controlled by this morel and catfishes. And if you go for the fish also feed aquatic intermediate hosts such as malaria causing mosquito larvae. Because in paddy fields, many times this mosquito larvae grow, and this is controlled if we rear this fish with the help along with the paddy fields. So waterborne diseases will be controlled if we go for the integration. And the rice field serves as a nursery to grow fry to fingerling stage of fish, because here there is no this is a this type of this in case of if you go for the pole this duck farming, and many times if you go for the very little stage of fish this seed and this fry stage, then many times duck may consume that particular fish also, but here there is no such type of problem. So here we can grow from fry to fingal stage, the fish can grow in the rice fields. Some disadvantages may also be there if you go for the rice fish culture. The farmer may face some problems. Particularly the agrochemical use is restricted. We have to restrict. The farmer has to restrict this agrochemical use because the fishes are there and they will act. The agrochemicals will act as a poison for the fish. So the farmer will not. Farmer has to stop this agrochemical use in the paddy field. The water level may not possible sometimes to maintain according to the fish size and growth, because the farmer has to maintain the water level as per the fish need. If the fish will grow, the water level should be grown. And fish sometimes grass carp may feed rice seedlings also. This is the a problem if we go for the grass carp integrated with their paddy crop. This may be the problem. This grass carp may destroy the paddy this plant. Common carp and tilapia may uproot the plant. This is also a problem. Sometimes this is because the large size they may uproot the plant paddy plant also. However, this type of problems may be manageable and can be managed by the help of this judicial managemental practices. There's another type of rice paddy or rice integrated fish farming. This is the rotational culture. In this system, rice and fish culture both are alternatively cultured or grown in the same field. The rice field converted into a fish pond after paddy harvest, and herbicide and pesticide. This is the advantage here. The herbicide and pesticide can be used because both the crops, both the this farming are taking at in separate time, not simultaneously. So here, this paddy field, the farmer may use the herbicide and pesticides for the paddy fields. There is another advantage is there. The greater depth of water can be given to the fish culture because there is no simultaneous farming. The another farming system of this livestock integration of fish farming with the livestock farming. it is also very get this important and going popular in the many type of many countries and many areas due to the this cutting of the labor cost, and also having the flourishing both of the business, both of the enterprise. If you go for the this integration of livestock with the fish, the integrated fish farming with integrated fish livestock farming. In this practice, the excreta of animals, it may be the animal, maybe the poultry, or maybe the duck, pig, or cattle, are either recycled or used by the fish, or serve as manure for fish pond. Either it may be directly consumed by the fish and used as nutrient, or either it may be recycled, or maybe it may act as fertilizer for plant, other plant, this and this which are consumed by the fish. This expenditure of using chemical fertilizer, supplementary feed cost can be reduced. We have not to use this sometimes this fertilizer for the pond, fish pond, because this animal excreta is a very good fertilizer and is used as fertilizer for this pond. This type of farming practices are done in several countries, and in India also. The income are realized more than typical fish farming system alone. If you go for the alone this fish farming, then we will not get this much income as in case of this integrated fish farming. So here is a very good this farming this picture. That's duck cum fish farming. This is a livestock integration with a fish pond. Here the duck, this is a duck stay here in the on this rafting type of this the hut is made for staying this ducks, and duck excreta are allowed to go in the this fish pond, and duck are free to go in the pond also. And this is very beneficial as integration, or we can say the symbiosis type of integration is there. Both of the this farming, both of the this livestock are getting this benefited by each other. So it's a very good picture. It is a highly profitable, and it is greatly enhance the animal protein production in terms of fish and duck. Because the main deficiency I have this started my this speak, that the deficiency or malnutrition is a very this is a problem in our developing countries, in India also. So in this, if you go for the in detail, this malnutrition is mainly this is the protein deficiency. So the protein source of a very great, it is greatly enhanced, and animal protein, as it is a good type of protein. So both of these fish and duck, this fish and duck per unit area production will improve. The fish cum duck culture is economically viable, technologically feasible, environmentally sustainable, and socially acceptable business which give high revenue. It is very important for any project that it should be economical viable, technologically feasible, and the important thing, this is the sustainable for the environment, and this also this socially acceptable. It should be socially acceptable. So this duck and fish farming have all the characteristics, all these good characteristics of this economical viability, technological feasibility, environmental sustainability, and the socially acceptability. If the farmer will go for this integration fish with this particularly the duck farming, this will he will get this he or she will get the very good amount of this profit with less labor. Fish cum duck farming is practiced in India. If we talk about the India, this in Tamil Nadu, Andhra Pradesh, Assam, and West Bengal, Odisha, in southern state Karnataka, Kerala, and in UP also. This fish cum duck farming this is a practiced in by these our farmers. This picture is not so clear, but we can take the idea. There is a duck house, and from the duck house, this water is there. This is the embankment area of the pond, and on the duck house, these duck are very easily there. A platform is there, and duck can easily go to the this pond water. And this, if you go for this in the bottom, duck is used for raking the pond bottom, which is very good for this fishes also. And this is also here the horticulture crops are also maybe grown on the embankment area of the pond. So this is a horticultural crop. So there is a benefit. This water may be used for the irrigation, and this duck is allowed to drop their droppings in the water. This is water, pond water, and these droppings will be useful for the fishes. The main, if you go for the main benefits of the fish from duck farming, so main is the manuring. Pond manuring is very important here, and the duck is allowed to manure this this feces or drop out in this pond water. So it is a very good manure for the pond fish. And soil raking. The duck is they have the habit to rake the bottom of the this pond. So it is a very good for the fish farming. And removing, sometimes this duck is used as a weed removing also, and supplementary feed is provided for this fish in form of excreta. Duck fertilize the pond by their droppings. The duck droppings contain, if we talk about that, the composition or little this important nutrient present in the duck droppings. So it have about 25% organic and about 20% inorganic substances are there in duck droppings, and many type of other elements like carbon, phosphorus, potassium, nitrogen, calcium, etc. are there, which are used as fertilizer for the pond. So we can say this the duck is also known as the living manuring machine, because it create the manure without any cost of extra cost, and it is very good for the fish pond health for their efficient cost and labor saving method of pond manuring. The pond water is also used for the cleaning of the duck house. It is advantageous for this duck farming or duck husbandry if we are using this pond water for cleaning the this pond house. The sale of egg and duck bring additional income along with the fishes, as there is this type of integration brings about nutritional security to farm family through egg meat in addition to fish. The farmer family will get the fish also, this egg and meat also. This will give the nutritional security. This will give the additional income, and there is a less labor requirement if we go for the integration. Here is the nutritional security. The farmer family of the, particularly the small and marginal farmer are there. This land holdings are very less. There's a so this such type of nutrition security is very important in form of fish, egg, and meat. If you go for a little bit about the duck husbandry, so this is we have this seen the picture. The pond embankment is used for making the shelter of the ducks, particularly in the night or as time of laying of eggs. These duck are allowed to stay in the duck house, and in daytime these are there are free access to the pond, so that there is no necessary to build a fence around the pond, because it is easy to go if the duck is need to rest. Uh, it will go to the this pond house very easily, and as it is very easy to go in the pond also. In case of light shelter, it is there is only this point 3 to point 5 square meter floor space per bird are required, and in a square meter area, this 15 to 20 number of this parts the cage may be there. This is this we have seen the picture. This is a floating pan or bamboo split made raft. This is in the on the pond water. This is a raft type of bamboo pan are there, in which this duck houses are made for and particularly this is important when we go for the large scale this integration with the duck farming in the with the fish. The this uniform manuring is important, and for that this multiple this bamboo split raft should be there, so that this duck can be used as a to allow to uniformly manure in the pond water. And what if we talk about the feed? This is this the same feed which are used for the poultry. It is used with the rice bran. Here is this one part of poultry feed with this two part of rice bran is used, and about 100 gram per bird per day is used as this duck feed. And kitchen waste also we can use. And duck start to lay about this 6 month age. This is 24 weeks age. Duck start to lay the egg, and it have the capacity of laying the eggs about this 2 year age. So this is the benefited for the farmer and rural this small farmer, marginal farmer. This is another very good photograph. This picture is there where this is a pakka house and another is a kacha. This hut type of raft is there in the pond. In this pakka house, this is in the left side. This a platform is there for easily movement of this duck. Ducks are birds are allowed to go in the pond water as they wish, and they are also allowed to go in the this house, pakka house, or the pond, this duck house, particularly in the night time. It's for shelter, and this is very easy. The manure, the droppings of the this duck are easily this allowed to go in the pond water. This is the some important quality of duck also, as we have seen in the rice or paddy plants or the fish, this particularly seeds. Here the duck should be sturdy or the hardy nature should be there, because that's extreme weather conditions sometimes are there, may be there. So it should be the sturdy and thus hardy in nature. And laying capacity should be good, so that this farmer may get this good income source. And the growth rate of the duck or the bird should be the 1 kg per year. These are the two breeds of ducks which can be used with the integration with the fish farming. And the very good is the khaki Campbell. If we go for the khaki Campbell, it is a very good for the integration, and it also lay that 200 eggs per year. And Indian runner, it is another breed on the right side. It is also maybe integrated with the fish pond. It is famous for the about this 150 this eggs per year. It is it lay. The stoking density, if we go for the stoking density, about 200 to 500 birds. If we talk about this khaki Campbell, that's about 200 to 500 birds are sufficient or ideal for the 1 hectare pond area. 1 hectare pond area. This is 200 to 500 birds. Duck are very good to integrate with the fish farming, and about 50 to 20 days old ducklings are good to use for integration. Duck droppings and manure. We have have talked. The droppings should be collected from the duck house at night and applied to the pond every morning. This should be the husbandry practice in daily routine. This duck droppings are collected in the night, and in the morning time. It should be this uniformly allowed to mix with the pond water. And if you talk about this fish system, as I have discussed, there is no problem. Such type of problem is there if you go for the integration with the paddy field. But here it is advisable to store a fingerling system, because if we go for the size of the fish, the fingerlings below fingerlings, this 10 centimeter or less size, it is there is a problem of this feeding by this duck bird if this feed if the size of the fish is less than 10 centimeter, and a stocking density of about 7500 numbers per hectare of the fish. If we are talking the birds will was the 200 to for 500 birds of in case of khaki Campbell. But here it is the 7500 number of fishes are easily cultivated in a area of 1 hectare. This is a study taken by the KVK Nymphe. The nitrogen-rich duck manure is very good for as manure or fertilizer for phyto and zooplankton. So silver carp and catla plus common carp are ideal for stocking. Also, other fishes, shrimps can be stocked in a polyculture manner, because this phyto and zooplanktons are very good this feed for the fishes, and sometimes the fish directly consume the excreta of the or the droppings of the duck. If you go for this complete economy of this 1 hectare this pond, then we will get the 3000 kg of fish meat or fish, 12,000 eggs, and 500 kg of duck meat per hectare per year. Maybe get by this farmer. If the farmer will integrate in a duck with a fish farming, then it will get this type of benefited. The same time of this integration with a chicken also. Duck is this is called this duck is the best, and another after that this poultry or chicken birds may also be integrated with the fish farming. The droppings of the chicken is same. Here is the phosphorus is also there. in along with the nitrogen. This additional this benefit of phosphorus is there in the droppings of the chicken. It act as fertilizer, very good fertilizer for the pond or for the phytoplankton and zooplankton. The poultry house may be constructed same manner as in the pond. This is type of this duck husbandry in the embankment area, and has no additional land is required for this purpose. It saves the labor in manuring, as the droppings directly enter to the pond, and the house made above the pond is very easy to allow this droppings to in the pond. The one thing is very here we have to this cautious that sometimes this coccidiosis is due to this wet problem. This is if we this go for the litter material used and it may get the wet. Sometimes coccidiosis is a protozoal disease. It may this attack on the this birds poultry in case of particularly in the poultry. So we have to take care. It's a managemental problem. We should take care that the litter should be dry. Let's talking of the chicken. The two breeds are suitable, ideal for this integration: White Leghorn or Rhode Iceland Red. WLH, the White Leghorn, is a very the best egg layer in the layer bird, and about 200 to 600 number per hectare here is the ideal. And the stocking density can be increased, the number of fish increase in the culture pond. And same number of fishes where this integration with the duck, 7,500 per hectare is same. The fish are reared in the 1 hectare pond size. Fish can stock in the fingerlings condition or lesser in size, because here there is no problem of taking this as a feed by the chicken, because chicken will not go in the not have the habit to go in the inside the water. It is a problem of with the duck because this less this fish should be less than 10 centimeters size. These are the two breeds, White Leghorn and Rhode Island Red. Another livestock farming is the pig cum fish farming. It is the same manner. The pig feces is also an excellent manure for fish pond. It increase the biological productivity of the fish production. And sometimes this excreta also have the 70% digestible food for fish. The pig excreta have the 70% digestible food for the fish, and it also have been reported that the feed which is passed through the alimentary canal of pig is mixed with a certain enzymes and which continue to act even after defecation. So it is a additional advantage of pig farming with integrated with the fish farming. The undigested solid present in dung, which is fed by the tilapia this variety of this fish, and the common carps or other species. No supplementary feed for fish is required here, because this pig excreta is very good source of this nutrition. And the pond dike provide for the pig sty. The pig sty is the space where the pig are allowed to rest, or the pig houses are there. It's called the pig sty. So pond dike are used as pig sty, and pond water here also can be used as a cleaning of the pig house, for bathing the pig also and cleaning of the pig also. The pond water may be used. And same thing here is the cattle cum fish culture is there. Same principle is there, like pig or this pig, or have you have seen this poultry or duck. Here in case of dairy farming, or if we go for the cattle farming also, this waste feed, urine, feces, and other farm waste are allowed to mix with the pond water. And these things, this is very good bio ingredient which are used as a fertilizer, inorganic nutrients, and which are very good for the phytoplanktons, zooplanktons, and sometimes they are directly this consumed by the fishes. Fish. So these type of integration are also very good for the farmer to improve their income. If you go for the advantages of integrated fish farming, so as we have discussed, this is a very profitable business and sustainable also. This very thing, the sustainability of this is very important. As in 14 SDG, we go for the life underwater, and there is a profitability for the farmer and also the sustainability for the environmental also. Environment cleaning is there, and there is a less the type of production of gases and other things which contaminate the environment. there is this type of problem are very less. And productivity also, this obviously it is improved due to the this use of both of the integration, and balanced food is there, because if you integrate with paddy with the fish, it is very good. Paddy is a cereal, and it will very good for the carbohydrate source, and the fish is very good for the protein. Animal protein is there, so it is very important to balance the food is there for this our to compete with the this malnutrition problem. Environmentally safe. It is, I have discussed this saving energy. Energy saving is very important in our this scenario in our for our earth, for saving our earth. And income around the year is there, because there is this direct sale of the fishes and this type of this product of the farming. This farmer will get the income around the year. And also the employment generation is there. Very good employment generation is there by if we integrate, if the farmer will integrate this fish farming with the livestock or paddy fields. So here I will conclude the this integration of fish farming (IFF) with livestock or paddy fields, or it may be also with the horticultural crops also. And if we conclude this, this is a very efficient and economic means of environmental management. This along with the a source of extra income to the our this farmers, small and marginal farmers. There's a full utilization of farm waste. The waste management is very important for any industry, for any enterprise. So here there is no problem of utilization of waste. It is used in benefit of each other, each enterprise. It will increase the employment generation, increase the nutritional source for rural family particularly. It gives a higher and stable farm productivity with less risk. There is a biological and economical risk very less. Here in case of integrated farming, there is no risk of this type of economic loss, because both of the enterprise will strengthen, give strength to each other, another enterprise. It increase the income of rural population, particularly the small and marginal farmer, which I have this talked. So, in nutshell, if you go for this integration, particularly the fish, because all the agricultural activities, because we have this my this previous this speaker, respected speaker, have told there are two type of food cultivation. Either it may be on the land, the crop, agricultural crop, it may be in the agriculture crop enterprise, or it may be the aquaculture. In both of the cases, if we this integrate both of the farming system, certainly it will strengthen this type of each enterprise and give additional income source to the farmers, additional this sustainability to the environment, and particularly very important to this this to this our this type of this malnutrition problem. So in nutshell, it is a very important tool to manage malnutrition, to sustain the environment, and to give the additional income source for our farmers. Thank you for listening, my dear participants and respected dignitaries, and special thanks to Honorable VC, the Subharti University, Masuta University, and another renowned dignitaries, and particularly Dr. Nisha Ranaji, for giving me this dais to express my views. Thank you.
Thank you so much, sir, for enlightening us. We are also thankful to you for joining us in the online e-workshop. Thank you so much, sir.
Thank you.
Thank you. So the next session will be started at 2 p.m. So we will join again by using the same link. The next section will be at 2 p.m. Good afternoon, sir.
Actually,
Good afternoon, sir.
good afternoon. Do you hear me?
Yes, sir, you are clearly audible.
Okay, okay.
Okay, now you can go on present.
But
There is
slide,
a gun on
slide,
your
slide,
just present. Present then screen. Slides, sorry, slide. Then slides.
slide.
Then slides. Then my computer.
Okay, okay. Oh, oh. Actually, my file is larger, so it is not. What can I do? I can I send to you? In that case, I have to shorter some slides. Please choose a smaller size. Okay. Oh,
Sir, you can go to the slide option,
but
slide option, then go to your
okay,
computer, then you can upload your file. So is it in PPT form?
okay, okay. Just please.
Please try again.
I want
Otherwise, you
to
can try again.
shorten some slide. What can I do?
Sir, you can go on the slide and
Okay,
then my computer, then upload your PPT.
okay. Oh, what can I do? Hmm, I have to say Kolkata.
Sir, if you are unable to share, then please share with us by email. Is
I
it
have
uploading?
IFSI.
So you can share with me, then I'll share.
But the problem is that slice. IFSI Kolkata. What is the problem? Ah,
Now it is not visible, sir.
uh, but is it okay?
Yes, sir, it is okay now. Now can we?
Okay, I want to start.
Okay, sir. Okay, sir.
Uh,
Now we are going to start the technical session. For this session, our invited speaker is Professor Binay Kumar Chakrabarti. Dr. Chakrabarti is a fisheries scientist and national and international consultant. As a leading fisheries biologist, Dr. Chakrabarti has been involved for a long period in many studies and worked as a formal project director in three projects in the Department of Fisheries, Bangladesh. In 1997, he completed an MS degree in planning in the Swansea University, Wales, UK, and also Bangladesh Agriculture University. He obtained his PhD degree in 2004 working on critically endangered fish species. He has been acting as a reviewer and editorial board member more than 28 different international journals. He has guided so many students and acted as an examiner of PhD students in the country and abroad. He is also a member of 18 national and international societies. About 84 scientific research papers are published in national and international journals, and 18 books are published by publishers. He has attended more than 86 international seminars of different countries of the world. He has conferred 7 awards of Lifetime Awards Achievement, Udayana University, Indonesia, College of Fisheries, Ibu Pantanagar University, Pantnagar, and many other societies like the Society of Life Science India, Global Research Initiative for Sustainable Agriculture and Allied Sciences, Society of Biological Science and Rural Development India, Global Environment Society and Social Association India, International Foundation of Environmental and Ecology India, Global Environment and Social Association India has again conferred the award of Dr. APJ Abdul Kalam Green Environment Promotion Award 2021 for commendable contribution in the field of environmental protection and social awareness, and International Foundation for Environmental and Ecology. India has been awarded Gilbert Environmental and Livelihood 2021. International Academy of Science and Research India has presented him a Scientist of the Year award in 2018. He has also been received the fellowship in 2019 from Asian Biological Foundation India, Award of Fellowship in 2007 from Zoological Society, Kolkata University, India, and other organizations. Now, I would like to invite Professor Vinay Chakravarti, Executive Director, Mud Eel Mud Crab Center of Agriculture, Aquaculture and Management Center, Bangladesh.
Uh, can I start now?
Yes, you can start.
Um, what has happened? Mm, Good afternoon to all. Good afternoon to Special Nishaji who invited me to participate in this online conference. I am very much pleased to her, and I am very much happy to participate this online conference. Actually, today's my presentation is all on aquatic resource and sustainable management in Bangladesh. What is actually happening? Uh, Actually, contribution, what is the contribution of fisheries and aquatic resources in Bangladesh? Provide a rural food security, employment, profit, save money, and fish production was last year 4.7 758 35 million metric ton was recorded. Fisheries sector contributes 2.08% of national GDP, 21.83% of the agricultural GDP, and 1.05% of the export earning, and fish supply 62.58 gram per day per capita. That is for planetary demand of per day. Actually, fish protein is the best protein, is recognized in the world than meat and poultry. And anyhow, 12% of people of this of my Bangladesh is anyhow their that is livelihood is related. Is livelihood is directly or indirectly related. So it's a very important sector in Bangladesh. Now I want to say, we know that uh, there are 17 SDG is declared by that is and that is the in that out of 17 SDG, that is nine SDGs very much related to the aquaculture and fisheries sector. How it is related? That is the poverty SDG one and zero hunger, and there is health and clean water, and that is the equality and economics also, and the culture and clean climate change, and that is the water. This is the um, issue of the SDC. And the SDC rank is 104 out of 163, and score is 64.22 is score. So we are very advanced. We are very advanced with our fisheries sector. Now, I want to say what the methodology. Methodology of this work is the development structure question has collected primary data by focus group discussion, that is FGD, and local ecological knowledge, that is LEK, and direct interview with the individual respondent, that is fisher, farmer, transporter, biker, other social worker, and other stakeholders. Secondary data was collected from mainly from the Department of Fisheries, relevant literature, and online. Data is analyzed in one way, ANOVA, using SPSS program. Um, so um, now I want to discuss about the sector-wise the production of fisheries production of Bangladesh. What is happening in an open water bodies? One sector that is capture. What is happening? The area is 3.9 uh, 2 million hectare, but the water bodies is related to river and estuary, Sundarban area, Gir, Kapai Lake, and White Lake, and the total production is 1.3012 million hectare. And types of even close water bodies, what is happening? That is the um, total water area is only 8.80 hectare million hectare, but it belongs to the sectors ponds, seasonal culture, water body, bow, shrimp and prawn farm, crab, crane culture, and fish culture. And total production is 2.6 4 million metric ton. And the contribution of marine sector, what is the contribution of the coastline is 710 kilometer, and marine contribution is 0.6812 million metric ton, and total production of the fisheries sector is 4.6212 million metric ton. Now, I want to say the biodiversity status of Bangladesh. Freshwater fish species is 260, freshwater shrimp species is 24, exotic fish species is 12, and marine fish species is 668, 468, and marine shrimp species is 36, and trotter is 22, crab is 12. Out of 12, four species are very important for our aquaculture of crab. Now, I want to say about the biodiversity status of 260 plus freshwater species. Out of 3%, three species are already extinct, and critically endangered is 21%, and endangered is 19%, and vulnerable status is 6%, and lower risk is 20, that is 37%, 32%, and least concern is 21%. The deficient is only 6%. This is the scenario of 2,260 species of Bangladesh. Now, I want to discuss about the real picture of a natural sponge production in riverine system. What is happening? What is happening? Here is the bar diagram. What is happening? Bar diagram is ups and down. Why it is happened? We know the declines due to loss of habitat. How habitat? Habitat is the river and other water body is siltation, pollution, overexploitation, collection of fish from the natural resources, industry, indiscriminate use of pesticide, fertilizer, like this. For that reason, the spawn, the number of that is brood fish is going to decrease day by day. For that reason, the habitat is not favorable for brood fish. The number of breeder is few, the production is few. This is a scenario of the natural fish production and production of artificial sport. This case, we are very much rich because of we are producing huge amount of um, that is produced artificial spawn. Basically, this is the scenario, and we are very lucky. We are going to produce huge amount of spawn. We can also export spawn from our country. This is the real picture of a total production of fish. What is happening here? 1983-84, 83.83 million metric ton, and last year it was the 4.769 million metric ton. And how it is possible? The production is increase record amount. So we are maintaining the basic need of general people of Bangladesh. The sector is divided into three groups. One group is equal to inland capital fisheries. That is, what is happening? The total production is, in that case, when 47, that is 1983-84, the production was this, and it is increased 1 point, that is 32% with the last year production. Although the production is increased, there are something wrong behind it. Now I want to discuss the contribution of Indian capture fisheries production, how it is happening. In 1983-84, the contribution of Indian capture fishery is 62.8%. In mid level 2007-8, it is 41.41%. And last year it is only 27.55%. So what is happening? Actually, the Indian capture fisheries production is downstream, decreasing day by day. So this is the issue. Now, I want to discuss about the river production and estuary production. What is happening? In 1982, it was 0.21 million metric ton, and last 1994 it was 0.14 million metric ton. So it is decrease again increase. How? Last year 0.84 million metric ton. How it is possible? It is possible only we produce via the Hilsa management policy. Hilsa management policy is very um, good to increase the production of riverine system. Um, this is the scenery of the that is blue terrace that Hilsa that is Hilsa conservation. Hilsa contribute 11.88% of total production. Production increased 2.79 to 5.68 metric ton. That is 2001 to 22. Activities, what the activities employ? The conservation of fruit is in peak spawning period. How it is banned period is declaring 4 days before full moon, 1 day full moon, 7 days, 17 days after full moon. So these days are totally prohibited to catch the fish from the river. Then, in the case of Zatka, another issue is applied provide food grain to the fishermen during the ban period, and management of 6 century. There are one, two, three, four, five, 6 century there. The management of 6 century is the essential to apply the fishery management policy in this area. For that reason, the production of Isra is on increasing. This is the scenario of the Isra production. The production is here. Uh, regularly increasing. That is the real picture. 0.87 million metric ton. So we are happy. We are increasing the production of this. It is a good luck for us. And production of Sundarban. What is happening? Production is Sundarban is maintained by the Department of Forestry. They have managed it so the production is the condition is up and down. Last year the production is increased. This is the style. This is the style. And what is happening in case of bill? Bill, in case of bill, it is ongoing, increasing. We are applying two management policy in the bill, two management policy in the bill. So it is easy to uh, uh, produce the huge amount of fish from the bill. Captain Lake. This is the scenario of Captain Lake. The production is increasing and apply some management technology here and release of fry in the Captain Lake. And in case of farming, it is also another issue to increase the production of fish in the floodplain. So we are very much lucky. We are increasing the fish from this floodplain. The contribution of Indian capture culture to fish production. What is happening there? This is the scenario when one was 1983-84 and now 2.73 million metric ton. It is a very good record, good production. So we are very much lucky by this time, but we have to ensure the uh, ensure the culture practice continue. So we have to alert about the culture of the that is Indian culture fisheries. What is happening? 1983-84, the production percentage was 15.53. Now it is increased. Last year, the production was 58.34%. So I think we are developing the agriculture sector very abruptly. Hope we will continue with production of corn. This is the scenario of production corn. It is ongoing. It is another issue for production. So we are lucky. We are increasing in the production of corn and tremendously. Uh, what is happening in case of fungus? What is happening in case of fungus? Fungus production is like this. 2013-14, the production was 0.67 and it is increased. It is that is 0.81 last year. The contribution of the total production is 8.53%. So, so fungus production should be continued regularly. And in case of what is happening to the tilapia, what is happening? Uh, the last year production is 0.11 and uh, not 0.81, 91. This is the 91, 0.91 production, and the contribution of the tilapia of total production is 8.54%. So it is a very good sign and symptom of tilapia production of tilapia aquaculture in our Bangladesh. Now, production of seasonal culture water body. What is happening? Seasonal culture body is the scenario of this. It is increasing by this soil. And in case of production of bower, what is happening? This is the bulk carp, and we are producing huge amount of huh? So, production in the power of it is a water body, just a tectonic origin, and it is a dead river like this. And in case of cement prawn, in case of cement prawn, the production is actually increasing, and we are exporting huge amount of steam in the outside and earning export earn the foreign currency. So we have to alert about the production of shrimp and prawns, production of crab. What is happening? This is the scenario of production of crab. Crab production is increasing, and we are exporting regularly crab from Bangladesh to Thailand, that is Philippines, China, like this country. So we have the grape production should be continue regularly. And what is happening in case of pen culture? This is the scenario of pen culture. Pen culture is also increasing, and the people are trying to practice the pen culture regularly. And case culture is also this type of their case culture is increasing in a big river and deep river. So it is a good sign and symptom of the development of agriculture of case culture. And in case of marine, what is happening? This is the scenario of the marine fishery. This is the marine fishery scenario. Last year, in the scenario of 0.71%. So we are very much happy uh, for increasing the production of marine. And this is the scenario of decreasing contribution of marine fisheries. 1984, the contribution was 21.88%, and 27-28 it was at 19.37% decrease, and lastly decreased last year 14.11%. So we have to alert. We have to alert. And I want to say some socio-eco-friendly technology. What is the technology? Technology is nothing. It is a car agriculture, small scale agriculture, captive agriculture, monoculture, and case culture, and land culture, vertical fish culture, integrated fish farming. And now we are practicing intensive, semi-intensive, highly intensive. Semi-intensive, we are producing monoculture than 1.5 million metric ton, and semi-intensive is 1.5 to 4 metric ton per hectare, and intensive is 4.1 gross metric ton per hectare, and lastly, in the highly intensive, it is higher than that is 10 million metric ton. So, it is a good sign symptom for aquaculture sector of Bangladesh. This is the fish we are culturing. That is katla, rui, miguel. That is lego calpaso, lego bonio, lego punta, sarana, lego vata, pangasius, fuchi, the exotic species. These are we are continuing our aquaculture. So it is very important. That is the bigger. It is nobilis and hypothalamus moltics and estimation idella. And this is a punta, sarana, stuff like this. So, so I want to say this is a very burning issue for us. Um, Now I want to discuss about the diversified indigenous fish culture in Bangladesh. Yeah, I want to start from here. Mr. Stengra. Mr. Stengra is a tender fish. Mr. Scabious is a butra fish. And on top of that, it is also these three species, not only all the species here we are that is spawning, nursing, and growing. So it's a very important issue for our agriculture. Here, on top of that, Mr. Scabious, Mr. Stanger, it was of Usulis and Claudia Vectors and our species here, and that is Mutia Sarana, the river water. This is Kanda Mola. This is Small Kandika. This is Chana Theatre. Sorry. Chana Theatre. That is Chana Theatre. Mutia Sarana. Stioranka Potio and Magnetus Anali, it is Caravan, and these species are mostly we are spawning by by industry and practicing nursing and culturing in aquaculture sector in Bangladesh. So we are very rich in this sector. Another issue is here is mud crab culture and I have developed the technology of model breeding and nursery technology. This model breeding is there and nursery technology is this here and this is also reproductive technology and we also develop two culture technology. One is aquaculture method this type, aquaculture method this type, and natural resource management is this type. So we also developed three culture technologies. One is juvenile culture. This is the nursery of crab. This is the pen culture. This is the pen culture of crab, and this is the social culture. This is technology. Both the technology of crab is also discovered by me. This is the issue. Now I want to discuss integrated fish farming. Integrated fish farming is a very important issue. So, agricultural fish farming is a income fish culture that is production is 2 metric ton per hectare, and this is the agricultural fish farming perimeter type. The central contact, in centrally the water bodies, the outside of the perimeter is the perimeter lateral strands like this. The um, fish Perigon fish farming. What type of species are culturing? Chana species, tilapia, magur, testogonia, super carp, common carp, ice, so like this. And another technology is horticulture cum fish culture farming and duck cum fish culture and cattle cum fish culture. Also, we are practicing regularly. So the contribution of fish production from agri-based fish farming is very good amount. Now I want to discuss about the advanced technology farming system where that is a bioflow. Bioflow itself is a flow itself is a flaw. So we should be alert about byproduct because you use the new quality the species which are very important for human being. You have to, if you do not culture this type of species in this byproduct system, it is not controllable. So only culture of tilapia is possible on biblock system. So we have to think about the biblock system. And another issue is the bottom in race culture. It is a very poor system in aquaculture but costly. We are producing 10 metric ton, not less than 10 metric ton from this technology. So it is a very warning issue. Uh, Now, what is happening in floodplain management? We are managing floodplain too well. Stocking of fingerling one, carp and other native fishes are declining due to the loss of habitat, silk transportation of pollution like this. And that is last year 48,994 metric ton fingerling release and record extra production was 0.456 million metric ton per hectare. And establishment of this is the technology of fly using, and this is the technology of uh, nursery development. How the area is 14,770 hectare, and the production is 16,294 metric ton. That is 1.102 metric ton per hectare production is recorded. Last year, as of this century, this type of river and river water body, we are establishing fish sanctuary. The number of fish sanctuaries is 432 sanctuaries in Bangladesh. We are regularly thinking about the sanctuary. Fish habitat liberation production of 3,200 metric ton additional from these technology that is fish habitat liberation. There is a dead, dead river sorry, there is that river and that canal, that water body, which is filtered, it is de-excavated. This is the system, this is the technology. Other thing, conservation of natural breeding ground. Yeah, there is a Halda River. It is near about your Mizoram. So it is protected for to get what can I say? This that is to huge amount of spawn from the Halda River. It is protected. So genetically improved spawn is found on this river. So it is very important river. Extension of plan farming. This is the plan is established and we are producing fish from the plan culture system. As a case culture, this system we are producing, and I have shown the production of plan, production of case previous slide. CBM technology, there are 400 million hours in Bangladesh. Area is 8 um, area is sorry uh, and this is the system we are producing. We are CDFM methodology is applied. We are first of all we are forming a community uh, basic for management, and it is ongoing. ID card of fisheries. Please, hello. ID card of fisheries. This is the system of ID card and traceability. This is the system of traceability, and we can produce help keep the food of supply of that is supply chain. We established the Fishery Diploma Institute, and this is very helpful for to create a mid-level manpower. It is another technology helpline gigs like this. This is a mobile phone. We are using mobile apps. The farmers, there is a apps is, when the farmers face any problem in the aquaculture, he is directly phone to the fisheries authority, and fisheries authority send the solution to his mobile, and the farmer can easily solve their problem. And I want to say now what is the that is challenge. What is the challenge? Challenge what production is will be rise 6.929 billion, and demand of cereal demand 1.143 billion ton within the 2000 that is 250. It is a challenge to meet up that demand. So, what is the challenge? Structural intervention. This is intervention should be removed or should not be established the the uh, without the getting the planning, without the I think it should not be established uh, without mapping or without thinking the biodiversity status. So it is a very fundamental issue. Pollution is another issue. Mineral emission water body is about the 50,000 of tons of BOD is already produced in the water body, and agrochemicals also the farmers use 250 pesticide in Bangladesh. So it is a burning issue for aquaculture. And plastic is also another issue for our aquaculture system. Between 1.15 to 2.41 metric ton plastic enter into the Bay of Bengal regularly, and recorded 15,346 lakh metric ton daily in the Bay of Bengal from 18 river of Bangladesh. Overexploitation is also a serious threat to 50% of species fully are overexploited. A lack of institutional management, it is also responsible for the beginning aquaculture. And advanced agriculture is also himself is liable for delay of or destroying the aquaculture system. Irrigation also is one of the another issue for the developing aquaculture. And sedimentation. This is also another change, physical structure and biodiversity of the river and wetland. So it is so we have to plan how to clear the sedimentation from the wetland. And alien species, it is another issue. These species are very burning issue in our country. and we restricted it, and government is banned this, not this species. Legally 24 even species are imported. So it is a very warning issue. Sucker fish, this dry sucker fish, 90% in Buriganga. So we are very much worried about our fisheries sector of Bangladesh. Effect of climate change. Climate change, agriculture is vulnerable to flood, hurricane, cyclone, storms, droughts, and like this. Effects on habitat physiology and reduce behavior, growth, and productivity capacity, change the breeding season and distribution. So it is a very burning issue for us. Now, I want to conclude my session by my want to lecture. Here, ensure quality seed and feed for agriculture, increase competition among land, water, and feed user, control the pollution, promote small-scale, low-cost agriculture, and improve reduction of environmental impact, need collaboration support between Department of Fisheries and other departments, that is agriculture, environment, and Noti Commission and land. Support of politician is needed, need to support conservation organization, need knowledge-based research and management. Finally, conclude the fish and fisheries support what as nutrition and food security, enhance foreign currency, changing social condition, and employment opportunity. This is the final conclusion of my presentation, and this is the reference on it. Actually, thank you to all listeners. I want to conclude my session. Thank you.
Thank you so much, sir, for enlightening us. The lecture was very innovative and illustrative. Thank you so much for enlightening us. So the next session will be start tomorrow at sharp 11 a.m. So please join us by using the same link at sharp 11 a.m. tomorrow.